Hi all, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to start the chapter Determinants. Determinants. As you are aware, we are going ahead with Kcet, and don't forget our target is to obtain 55 plus marks out of 60. 55 plus out of 60. But surely 60 is also achievable. I'm just bit, I can say no, precaution. Now, as I discussed in determinant chapter, that I mean to say matrices chapter, that I'll be giving synopsis as well, a detailed synopsis. So now coming to determinants also, there is no need to worried about what about the concept of PUC. I'll be going with concept of PUC as well as with respect to additional concept which is required for Kcet. Now let us understand what is a determinant. It is a function. It is a function which maps every square matrix A to a unique real number provided all the entries are real numbers. Let I just see a recording. So we usually when it's a function, no, f is a function from A to B, correct? So now determinant, we use a symbol delta. So in place of f, delta we have got, where every square matrix, let's say capital M is a square matrix, is mapping to a unique real number. So if I have got a matrix, let us suppose A is equal to 1, 2, 3, minus 4, which is a square matrix. M is a square matrix. M is a square matrix. So I'm writing here n cross n. Okay. And it's going to map to a unique real number provided all the entries are real numbers. Now here I talk about the determinant det of A, or just the symbol is delta, or it is determinant. All the three symbol, okay, means the same. Det, first three letter of the word determinants. So this C coming to matrix is a rectangle box or a small bracket, both are fine. But coming to determinants, a parallel line, and here 1 is there, 2, then 3, then here minus 4, then here plus minus, then you can just cross multiply plus. See here the sign whatever we have written, you should multiply with this sign also. We are not changing the sign. To be specific, I'll do one thing. I'll change the question to minus here, so to understand that we are not changing the sign. We have to multiply this. Plus into minus, minus, minus to minus, plus. 1 into 4 is 4. Then minus into plus is minus. 3 into 2 is 6. So answer is minus 2, which is a real number. The number can be positive, can be negative, or can be 0. So here every square matrix M is mapped to a unique real number. Okay, we can think like this, M. So I have got set of all matrices. Okay, I'll just give some capital letter A here. So every square matrix is being mapped to a unique real number K, set of real numbers. Okay, so this delta of small m, okay, let's say this is a capital A. So when I'm going to map here, so I can just say that now this is delta is taking, so delta of A or determinant of A, or the symbol of modulus. Don't be confused with the modulus sign here. Symbols are same, but meaning is different. For modulus, inside this number used to be there, but here matrix. Okay. Now, having understood this, let's try to recall how we are going to evaluate determinant of 1 by 1, 2 by 2, and 3 by 3. And determinant is only performed for a square matrix. Okay. And here I said real number provided the entries are real number. See, it may also happen that no, let's suppose the entries are complex number, I may get complex also. I mean to say, one example is taken. This is one example I have taken. One more example. Let us suppose that I am going to have a matrix I 0, 0, 1. I want to find the determinant of this. How are we going to find? Plus, minus. So I 0, 0, 1. Yeah, here plus and minus. Cross multiply. I into 1 is I, where I is root of minus 1, which is not a real number. So I'll get I minus 0, nothing but I, which is not a real number. So if all the entries are real number, only then I can get real number. If it is not so, I may not get a real number. If I could have got here I into I will be I square. Then I square is minus 1. I'll get a real number. Okay. So it just depends on the entry. Now let us recall how we are going to evaluate 2 cross 2, 1 cross 1 and 3 cross 3. So determinant of a matrix of order 1 by 1. Understand here, we want to evaluate what matrix. I want to find the determinant of this of order 1 by 1. So let us suppose we have got, if A is equal to matrix A, then determinant of this is only A itself. Just see, now here when I wrote A, I want to be very specific here. Order of this is only 1 to 1 column, so 1 by 1. So if I take one example here, if I say A is a matrix with containing 2, then determinant of this is what? 2 only, first example. Second example, if I say B is a matrix with element minus 3, then determinant of B is what? Minus 3 only. It is not going to change the sign. Similarly, if I say that C is a matrix with element 0, then determinant of C is what? 0 only. So whatever the entry you have got, same output you are going to get for 1 by 1. Similarly, now let us try to understand determinant of order 2 by 2. This is all example of determinant of order 2 by 2. Let I just give the heading. This is what? Determinant of a matrix of order 2 by 2, or I can just say of order 2, but I'll be very specific, 2 by 2, because I can black color. Okay, and this is how we are going to evaluate. Now let us talk about this is the first point, this is the second point. Coming to third point, determinant of order 3 by 3. Determinant of a matrix of order 3 by 3. So we want to evaluate, but the order is what? 3 by 3. Now see, if I have got a matrix A with some entry, suppose A, B, C, then D, E, F, then G, H, I. I want to expand this. These are 3 cross 3 matrices. Then what will be the determinant of A? See, here when we expand A, add the first element here, delete the row and column where A is present. When I delete the row and the column where A is present, we are going to have the remaining. Delete the row and column where A is present. So first row and first column gone. So E, F, H, I. Then B. So here plus minus plus will be the sign. Minus to plus is minus B. Again we are not changing the sign. We should multiply minus into plus is minus. So minus B. Delete the row and column where B is present. So delete the first row and the second column. Then what we are going to have, if I delete the first row and second column where this B is present, we are going to have, don't forget we have a minus here. So delete the first row and second column, we'll get D, F, G, I. Then plus into plus 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 C. So delete the first row and the third column, D, E, G, H. D, E, G, H. Okay. Now from here, this each of this determinant is of order 2 by 2. We know how to evaluate. So we are going to have here plus minus, then plus minus, and again plus minus, and then A into multiply now. Yeah, cross multiply, plus into plus 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 E into I is EI, minus F into H, then minus B into D into I is DI, minus F into G, plus C into D into H is DH, minus E into G is EG. This is how we are going to evaluate determinant of 3 by 3. I want here you to understand one thing. The determinant of 3 by 3 can be expanded in 6 different ways. How many? 6 different ways. 3 by row and 3 by column. Okay, before I just talk about that, first make a note of this. Let us erase and let us have some space. And before I go ahead, if we talk about function, types of function, where it is one function, onto function, many one function, and into function, then bijective function. Determinant, as we have said, is also a function which maps every square matrix to a unique real number. Hope so it's recording. Yeah. So what do you think? Determinant is which type of function? First of all, it's a function. Why? The output is a unique real number. Whatever matrix we take, if I take the determinant of that, I get a unique real number. Unique real number. Unique real number. Yeah, always unique real number. So determinant is a function, undoubted, no doubt about it. But my question is, which type of function it is? Which type of function is a determinant? If we talk about types of function, see carefully. I can have in determinant, if I take a matrix, the determinant of two different matrices can be a same number. For example, okay, let I erase this. First, let I erase this and then let us have some space. Okay, dear students, as we were discussing about types of function under which type the determinant will come, so I'll just take 2 by 2 matrix to make it very clear. See, if I give one question, what is the determinant of 2, 0, minus 1, 2? Okay, I will do one thing. I'll take this as also 0. So we have plus minus 2 into 0, 0. Minus plus 0 into 1 will be also 0. So I got 0 here. So the matrix with the element 2, 0, minus 1, after taking determinant, will get 0. Similarly, if I take a very easiest, this is also what? Cross multiply, plus minus 0 minus 0, nothing but 0. So you can see, I have got two matrices. I'm saying matrix, even though I didn't wrote here, don't forget what is determinant. It is a function which maps every unique, I repeat, it is a function which maps every square matrix to a unique real number. So matrix rectangle box I have taken as a determinant, then I have got the real number to be what? 0, 0. So this is a, therefore I can say that determinant, the image whichever they have got, no, these two have got same image. So determinant is not 1 function. When I say it is not 1 function, that is, it means determinant is many one function. Many one function. It is, and it is onto function. Why onto? Always the output is what? Real number. It can be any real number. So it is many one and onto function, determinant. Now let us try to talk about what are the different ways of expanding 3 by 3 determinant. We can expand only 6 ways. See, and how the 6 ways that I just quote here. If I've got determinant of A, that is I'll take as A, B, C, D, E, F, G, H, I. Okay, so now one way we can say along first row. Now if I go with second row, for that now you remember this diamond sign which I call diamond. See this. Whatever the entry we have got for 3 by 3 determinant, any 3 by 3 determinant. So if as soon you write this A here, then let us write it bit below. A here, B here, C here, then D here, E here, then F here, then G here, H here, and I here. So always what you are going to do is you are going to multiply this negative sign right on the top of the element. So if you are going to expand along first row, that is plus minus plus. When you expand along second row, then see plus minus plus. So there is no, so when you are going to go for this row, I repeat, when I am going to go for second row, it is minus plus minus. When you go for third row, plus minus plus. Again I repeat, when you are going to expand along first row, you see the sign plus. There is no change here. Only for this term we have to multiply negative sign. Okay, along first row, which I did here. Coming to second row, just see here. As soon as I see this diamond, diamond sign. So here it is only minus and here plus. I have to multiply. Sorry, both are minus. I mean to say here and here. So how I'm going to expand? Just see this carefully. When I'm going to expand along the second row, minus to plus is minus D. Leave the row and column with D there. First means second row and first column. Remaining is B, C, H, I. B, C, H, I. then plus E, leave the row and column where E is present for second row and second column, then A, C, G, I, then minus plus is minus F. Leave the second row and third column, we'll get A, B, G, H. So plus minus, plus minus, plus minus. So minus D times of multiply B into I minus H into C. Then plus E times of A into I minus CG. Then minus multiply again this to A into H minus B into G. In this way, you are going to expand and get the result. This both after simplification, multiplying will get the same term. So I have just given you how are we going to remember which sign should be given. And this in detail we are going to again discuss it minus and cofactors. Okay, actually we are multiplying minus with cofactors. Element, I mean to say, I am multiplying the element with its own cofactors. That's how we get plus minus plus or minus plus minus plus or minus plus minus, all that. Okay, 6 different ways we can expand a determinant of 3 by 3. Let us comment here. Note a determinant of order 3 by 3 can be expanded in 6 ways. 6 ways. 3. Which are the 6 ways? 3 by rows and 3 by columns. Okay, so let's take up the 2 properties. I'm just going to list out without any proof, and then we'll take up the problems. Kindly make a note, and as I said, make sure, let me have a book in front of you and write down the important notes which I'm giving, like 6 different ways we can expand determinant. Who knows, they may ask for 1 marker, and it's a which function, minimum and onto function, every determinant. Fine, all the very best. Let's go for next. Dear students, having understood the definition of the determinants, let us try to understand some of the properties. See, the properties are going to serve as a shortcut for this chapter as well as the previous chapter, matrices. See, we understood how to expand 1 cross 1, 2 cross 2 and 3 cross 2 determinant. 3 cross 3 we can expand in 6 different ways. That's also explained. Now, some of the properties to be understood. This is going to serve as a shortcut for our problems. First one, if you talk about any determinant and if you take the transpose of the determinant, both are same. How, sir? Simple. One example we'll take. If I take A is equal to a determinant A, B, C, D, and I'm taking purposefully 2 cross 2 because my working will be a bit faster. This is for any order. Okay, so now cross multiply A into D, AD minus B into C, BC. Now if I take transpose of this, so AB, the first one will change to first column. Same transpose whatever we have got in matrices, same thing for determinant also. Row will change to column and column will change to row. CD will be this. Okay, now transpose we have taken again. For level, have I taken transpose? Yeah, yes, I have taken A into D, AD minus BC. Yeah, very clear, both are same. That's what we are saying, that determinant of A and its transpose both are what? Same. Okay, next. If I talk about A power n determinant, what's the meaning of this? We have a matrix A, multiply n times and then take the determinant. This is same as determinant of A whole power n, both are same. Next, determinant of A into B. If I have got product of 2 matrices and I want to take the determinant, we think that first we should multiply 2 matrices and then take the determinant. We are saying that we can also do one thing. First you take the determinant of each and then multiply. Both will be a real number. Multiply them. That's it. This is not only going to be for 2 matrices. It can be for n number of matrices. Let us suppose ABC. So again, determinant of A, determinant of B, determinant of C. Or I can have in general n matrices, matrix A1, matrix A2, up to matrix EAN, product of the matrices. we can just write as determinant of A1, determinant of A2, and up to what? Determinant of AN. Okay. Next, one more thing to be understood here is point number 4. Whenever you see this carefully, just see this. I'm going to have A, B, C, 0, D. Okay, A, B, C, no, D, E, F. Just see carefully. Just see carefully there. This is zero-minded. And this is D. A, B, C, D, E, F, G, H, I. Okay, I will take. What can you observe first carefully here? I've taken a determinant here such a way that in the first one, with respect to diagonal elements, that is A, E and I, all the elements below the diagonals are 0. In the second determinant, with respect to the diagonal element A, E, I, all the above diagonal elements, all the elements are zeros. And again, with respect to the diagonal element A, E, I, both above and below all are zeros. And I repeat again, with respect to the diagonal elements A, E, I, in the first determinant, all the elements below the diagonals are 0. In second determinant, all the elements above the diagonals are 0. And with respect to the diagonal element, both below and above all are 0. Then the answer is product of the diagonals A, E, I. That's it. A, E, I. You can expand and see yourself. For example, if I expand, what will you get? How do I will expand? Plus, minus, plus. So A into, leave the row and column. So you get A means E, 0, 0, I. Then minus 0 plus 0. Okay. Then what's the answer? Plus, minus. So multiply, you get A. E into I is EI, then minus 0 will be EI itself. That's what we wrote here. So from this we can also say that this actually, if I talk with respect to matrix, it's a diagonal. Okay, only this is diagonal matrix. Okay, for whenever we have a diagonal matrix, the determinant will be product of their diagonal elements. Okay, but these are not diagonal matrix. If I talk about matrix, okay. Now from this we can also say that what? If I talk about any identity matrix determinant, for example, identity of order 2, it will be what? 1, 0, 0, 1. So no need to expand. It is of this form. With respect to diagonal, both above and below are 0. So as is product of the diagonal, 1 into 1 is 1 itself. So in short, determinant of any identity matrix is 1. Okay. One more note. If I have a determinant, okay, let us suppose I've got any determinant in which any one, all elements of a row or a column are 0. So here first row elements are 0. Expand this, what's the answer? You get 0. Similarly, let us suppose that I have got, I'll take 3 cross 3 now. 3, 2, 1, 0, 0, 0, 1, 2, 3. I have taught you 3 or 6 different ways of expanding, and here since the third row is 0, I can expand along, second row is 0, I can expand along second row. There the sign will be here minus, then here also minus. So anyway, when you expand, minus 0 if anything is 0, then plus 0 if anything is 0, then minus 0. So in a determinant, if all the elements of a row or a column are 0, then the value of the determinant is 0. Right, I mentioned here, that is, if all the elements of a row or column are zeros, then the determinant is 0. Therefore, we can say that whenever we talk about 0 matrix, which is square matrix, since all the elements are 0 only, the answer is always what? 0. Determinant of 0 matrix is always 0. Okay. Next, I'll just give an example here that I have just also taken. This is standard result now. This is a standard result. On that, I have taken every 0 matrix determinant. If I take that is a square matrix, it's always what? 0 only. Similarly, see this carefully. Take 7 point this side. Here you see A, B. Here I have got Ka, Kb. Expand this. Kb into A, Kab. Again multiply minus Kab. We got what? 0. See carefully what's happening. The corresponding elements of these two rows are proportional. Can you see? A divided by Ka. B divided by Kb. A will get cancelled. I get what? 1 by K. So whenever in a determinant, if you need two corresponding elements of the I repeat, in a determinant, any two rows or any two columns corresponding elements are proportional, then the value of the determinant will be 0. Let's comment here. That is, in a determinant, if any two rows, same whole goes for columns also. In a determinant, if any two rows or column corresponding elements are proportional, then the value of the determinant is 0. The value will be what? 0. If any two corresponding rows and columns are proportional. That's what we can see here. Okay. First, make a note of this. Yeah. Let us proceed. And before that, here now, I would like to add one more point. Since we know that determinant of A and its transpose are same, so the third point, for all these matrices are same, determinant same, it can also happen that I can have A transpose into determinant of B, then also no problem, value will be same as this. It can also happen that determinant of A, then determinant of B transpose, even if I take, then also the value will be same, because determinant of A and its transpose both are same. Even it can also happen that determinant of A transpose into determinant of B transpose is also same. So all, whether both are transpose, any one of them transpose or without transpose, all will be equal to determinant of A into B only. Okay. Similarly, I can also say this is determinant of A transpose B transpose, that also same only. Okay. Now one last thing I want to discuss. I just forgot the number. What was the number? Is it visible? I'm not able to recall. Just next note. Okay. Next note. See this carefully. A, B, C. For this, I will have one scalar multiple K for level. Let us suppose that I have A, B, C, D, E, F, G, H, I. Let us expand this. Just C for level. You know how to expand? Plus, minus, plus. And very fast, I'll expand this. E, I, F, H. Right? Then minus B, D, I, minus F, G. I want to give one result. So let us expand this. C times of DH minus GE. Is it correct? EI, FG, DI, FG, FH there. Fine. Now, this node which I am taking, this is my equation number 1. Now, let us suppose, I'll take this determinant. This is the delta. Now, I'll take delta 1. Delta 1 is this. KA, KB, KC. This is LD, LE, LF. This is MG, MH, MI. Okay. Now see carefully. Expand this. Plus minus plus. What you are going to have? Ka. Leave this one column. We will get Le. Okay. Le into Mi minus Lf into Mh. Then minus Kb. Leave the first one, second column. Ld into Mi minus Lf into Mg. Then plus K into C. Leave the first one, third column. Ld into Mh minus Le into Mg. Let's simplify this. Delta 1 is equal to here KAL EMI, then minus KALFMH, then minus KBLDMI, minus, let's multiply, minus plus KBLFMG. Next, multiply this to KCLDMH, then minus KCLEMG. Okay, now just see what's common. Let us write what are the common things. Can you see common throughout? K. Fine, K. Next, L. Okay, fine. Next, M, and M. Yes, those are things common. Remaining is what? I don't know. A, E, I. Fine. Then here minus A, F, H. Then minus B, D, I. Next plus B, F, G. Next plus C, D, H minus C, E, G. So what are trying to make us understand? Now come back here. Multiply this also. What you are getting? Multiply this. AEI minus AFH minus BDI minus plus BFG, then plus CDH minus CGE. This I will take as equation number 1. Compare now. Are they same? This part. Compare this part. Only this part. Yeah. AEI. Yes. Okay. So now let us write KLM as it is. This from equation number 1 is this determinant. Let's copy that. What's that? ABC. Then DEF. Then GHI. But what is the left hand side? This one. Mention that. Determinant of KA, KB, KC. Here LD, LE, LF. Then MG, MH, MI. What have we understood from here? See carefully. Here K is common, or K is present in first row. K is multiple to each and every element of the first row. That we have taken out. That K is taken out as a common, you can say. L is present as a multiple in second row for all the elements. That's taken out common. Then M, taken out. In matrix and determinant, here you can see the differences. In matrix, if at all you want to take a scalar out common, that scalar should be a multiple for each and every element. For the while. Time is there. Okay, I have to go to college, no? So see here. What I want to say from here is, if at all you have got KA, KB, KC, KD. Okay, let's take 3 of 3 only. Okay, KC, then KD, KE, KF, and here KG, KH, and KI. In a matrix, if at all you want to take a scalar out, it should be a multiple for each and every element. Only then you can write as k times of the remaining, that is A, B, C, then D, E, F, then G, H, I. Correct? But in determinant is not like that. As soon as an element is present in each row, then you can take this as common out. You can see K, 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 first row element, in the first row it is present. So I can take K out. Remaining is ABC as it is. As soon as you see here, L, L, L present in second row, I can take it as common. And M, 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 then in third row, I can take it as common. Now, let us suppose all the scalars are same. Let us erase this side. Then I can conclude. This is our last result. Then we'll take the problems. Now see carefully what I want you to understand. Let us suppose now here, this one result I hope you understood. Now it is suppose that I have got in place of K, L and M, all are K only. So K, KB, KC, then K, D, K, E. I'm taking L, M to be what? K only always. Then KF. Then next what? KG, KH, KI. A very important result we are going to get now. Since all are same, K, L, M, all are equal to K only. So K into K into K will what? K cube times of what? A, B, C, D, E, F, G, H, I. What I'm trying to convince you here, what I want you to make you understand is, if the scalar is present like this one, K, K, K throughout, just you can take common out and it's K cube, and this power 3 is order of this determinant. Order of determinant is 3. Determinant is 3. So if I take this delta to be as determinant of A, then I can write this one as, not even this, not even this, this one as delta to be determinant of A. Then I can say determinant of A is equal to K. Okay, fine, I'll take this as delta, this is better. So now then what I'll write? This is K times of determinant of A is equal to K power N, okay, K power 3 we have got, into determinant of A, where 3 is order of the determinant matrix A, or order of determinant A, determinant A, or order of matrix A. Better, matrix A. Okay. Now you see here also same thing. In general, determinant of A, K into A will be K power N into determinant of A, where N is order of matrix, square matrix A. A very, very, very important result. How it comes, I have just explained. Here, as soon as we take KLM, same as the given scalar K, then I'm going to have a power, and that power will be same as what? Order of the matrix here. I hope this point is clear. Remaining, now we'll take the problems now. Kindly make it out. Now let's move on to the problems. Ready? So evaluate. The first problem from determinants. Yes, surely what I'm trying to do henceforth is, as and how I take the concept, I'll try to finish then and there is the problem. So I have taken the problems on the concept of expansion of 2 by 2, 3 by 3 determinants. Okay. Now, when I go for the adjoint concept, then we'll give the properties, the synopsis. Okay. Now just see. Evaluate. We have to evaluate this. We have a determinant. So plus and minus here. So here, multiply cos into cos. Cos square 15 degree, because angles are same. Minus plus. Here, sine into sine will be sine square 15 degree. Now to evaluate this separately. We know the result. What is cos square theta plus sine square theta? It is equal to 1. If I could have given theta and theta here, surely as soon as you get this, it will click for you this one. But as soon as some angle is given, no, students are in confusion what to do. And don't forget, this is true for any angle. And in place of theta, we have got 15 degree. So since it is obeying this formula, answer is 1. So option C, Chalu, is correct. Okay. Now let us move on to the next problem. Now you will understand the benefit and importance of properties of the determinant. Question says if A is this matrix, B is this matrix, then evaluate determinant of A into B. Many students, what they will do, first they multiply A and B, then take the determinant. But I will just state one property here. Determinant of A into B is same as determinant of A into determinant of B. First, make a note of this. Not only for two matrices here, product of two. If I have got product of n matrix also, we can separately find the determinant and then we can multiply. This will be easy and we are going to save the time. Don't forget in 70 minutes you have to answer 60 questions. So this type of properties will be a shortcut for us. So determinant of these two I have to find. So I can find individually. So I can just find determinant of A into determinant of B. That is going to give this result. Correct? So I can just substitute directly here. No, is equal to determinant of A is what? 1, 2, 3 minus 1. Determinant of B. 1, 3 minus 1, 1. You can also solve simultaneously and comment in the chat box. So you have plus here. So plus into minus is minus. 1 1s are 1. Then minus 2 into 3 is 6. So product here, be careful, product here, because the product of two determinants. Then again, a bracket here, 1 into 1, 1, minus into minus is plus, 1 into 3 is 3. So minus 1 minus 6 is minus 7 into 1 plus 3 is 4. 7 4s are 28. So minus 28 is the answer. Option C is correct. So determinant is making your job easier. I mean to say property is making your job easier, not determinant. Okay. Now see this. Here I have taken a question. If determinant of these two are equal, then find the value of x. Many students will have a trouble here that they are just blindly going to equate. See whether you have here 5 5 here, 8 and 8 here, and here just 9 as it is, suppose. Okay, 3 here. You're not going to equate this is equal to this. It's not a matrix. It's a number. It's a determinant. Output is a number. So you are going to expand this. You are going to expand this. Then you are going to solve the obtained equation. Okay. It may be a linear equation, quadratic, cubic, depending on the power of x you get after the expansion. You are not going to equate the corresponding term. That's the motive of taking this problem. As soon as you have got parallel line, it is determinant. So see here, plus, minus, plus, minus. So 2x into x will be 2x square, minus into plus will be minus. 5x, don't forget it's a minus here. 5x are 40 is equal to 6 into 9, 54. Then minus to minus plus 2 into 7 is 14. Borrow 1. 2 ones are 2, 3. 2 sevens are 14. 2 ones are 3. Now, since I have got degree 2 and I want the value of x has been asked, so simplify. If I transpose this, we are going to have 2x square is equal to 40, and this addition will be 4, 4, 8, 5, 6, 7, 8. Yes. Again, if I add here, I get 128 is equal to 2x square. Divide by 2. 2 1s are, 2 6s are, 2 4s are. So x square is equal to 4. I want only x value. It's a quadratic. We are going to expect two roots, and the roots will be x is equal to plus or minus root of 64 is 8. So option C is correct. Suddenly one doubt will come for many students. Sir, you said function means a determinant is a function. So every element should have a unique image. But you are getting two images. No. We are getting one image. See, this image of this is 128. And this is an equation we have got. And for this equation, we have two roots. We got an equation here. So it means to say that for plus 8 as well as minus 8, we'll get the same value. Okay. Now let us proceed with the next. The roots of this equation. Now here I have taken a 3 by 3 determinant, plus here, minus here, plus. Now, what is the purpose of knowing that we can expand the determinant in 6 different ways. Wherever you have got maximum number of rows in a particular row or a column, you can think of expanding that particular row or a column to save the time. So as you can see in this particular question, in the first row we have got 0, so I can anyway expand, or even in the third row. I'll do one thing. You expand in first row, I'll expand in the third row, because third row also I got 1 0, and let us see whether your answer is matching or not. You are going to comment in the chat box. Okay. So for that recall, I said one diamond. No, here one diamond. Only the element whenever I'm expanding, only there I have to change the sign. So since I want to expand along row 3, R3 means R stands for row 3. So see, here the sign should be plus, then minus, then plus. If I expand along row 2, then here minus, then plus, minus. Row 1 we already know. Similarly, column plus, minus, plus. As soon as you can see the diamond, one edge, plus, minus, plus. Here minus, plus, minus. Here plus, minus, plus. Okay, now let's see. Plus 2 times of plus into plus plus. Leave this row and this column. Into the third row and first column, we are going to have remaining 0, 8, 1, 3. Okay, now I remove this. Now minus 0, no problem, nothing to multiply because 0 and anything is 0. Next, plus into plus plus x. Leave this third row and third column. Then what we are going to have x0, 4, 1. x0, 4, 1 is equal to 0. Check once, have we did things correctly? Yeah, okay, fine. And then yes, fine. Now expand this. When you want to expand, this is plus minus, and then here plus minus 2 times of 3 into 0 is 0, minus 8 ones are 8. Then plus x times of x into 1 is x, minus 4 into 0 is 0. Then 2 into minus 8 is minus 16. X into, and x minus 0 is x. X into x is x square is equal to 0. So transpose this. X square is equal to 16. X is equal to plus or minus 4. So we have got plus or minus 4. There are two roots, and that is present in option A. I hope even if you expand by, if you have, surely you might have expanded and you have got the same answer. If not, kindly cross check. This is correct. You can also go for second column, here, then third column, first column, you'll get the same answer. Kindly make a note. Yes, dear students, let's proceed. And I would like to just say, if you just see previous year set of Kcet exam, we can expect some 4 questions, 3 to 4 questions from here. Okay, 3 to 4 questions. And don't forget, our target is 55 or 50. Okay, 56 plus or 55 plus, whatever we have said. And it should be actually 60 or 60 only. Just I'm bit precaution for 60. Okay, let us go ahead. If this determinant is equal to 8, hope so it's recording. Then the value of x, trigonometry I have taken. See, as soon you get trigonometry, don't get panic. Just first solve it. Okay, so evaluation of 3 by 3 determinant. It's a no very difficult one. So plus minus plus. So x into, leave this row and column where this x is present, remaining is this, so I'll get minus x plus 1, 1 and x. Then minus plus is minus sine theta, leave the row, first row and the second column, remaining is minus sine theta, 1, then cos theta, then x, then plus cos theta. So leave the first row and the third column, we are going to have determinant of what? Minus sine theta, minus x, cos theta and 1. Now this is equal to 8. Okay, now simplify. X into plus minus. Minus into plus is minus. X into x is x square. Then minus 1 into 1 is minus 1. Then minus sine theta of, again plus minus. Plus into minus minus. Multiply x into sine theta here, then minus 1 into cos theta is minus cos theta, then plus cosine of, plus and minus here, multiply, plus into minus minus, sine theta into 1 is minus sine theta, minus minus is plus, x into cos theta is equal to what? 8. Now simplify this equation. Plus into minus minus, x cube here, plus into minus minus x, then minus into minus will be plus, x as it is, sine into sine will be sine square theta, minus into minus is plus, sine into cos theta. Then what next? Plus into minus is minus, cos into sine theta, cos theta, sine theta. Then multiply this one, plus x, cos into cos is cos square theta is equal to 8. Now without any difficulty, some of the terms will get simplified, which are those. See, plus sine theta cos theta and minus cos the sine theta will get cancelled. and remaining, you shall see remaining is, I'll do one thing, I'll solve it here, okay, then I'll erase it, okay, continue here. So what is the remaining part? Minus x cube, then minus x, and here can you see for this 2, can I say x is common? So if I take x common here, I am going to have from here sine square and here plus cos square. So the remaining is sine square theta plus cos square theta. So this is done, this is done, this is done, is equal to 8. What is sine square plus cos square theta? 1. So remaining will be minus x cube minus x, x into 1 will be x, is equal to 8, plus x minus x will get cancelled, or I will get minus x cube is equal to 8, or x cube is equal to minus 8. Cube root of minus 8, if I take the cube root, x is equal to cube root of minus 8 will be minus 2. See, square root of negative doesn't exist, but cube root, odd root, if I take, always I will get the answer. For positive also, negative also, x equal to minus 2 is the correct answer, option W. Now let us suppose in a question they asked you, we want all the roots. See, degree is 3 here, so we should expect 3 roots, but we have got only minus 2 as a real root. The remaining 2 are what? Imaginary root. So let I just give you that also. If at all I am asking you the cube root of a3, then the answer is a omega and a omega square. So on that basis, if at all the question was what is the cube root of 8, cube root of 8, then the answer will be, first cube of minus, I mean to say cube root of minus 8 will be minus 2, then minus 2 omega and minus 2 omega square. Okay, if at all they say with respect to complex number, get the answer. Since they have not mentioned, it's only real. Okay, fine. Kindly make a note. Dear students, let us first move on to question number 6. Question number 6 says, oh, for a while is it? Question number 6 says, and again I am saying repeatedly, kindly make a note of the properties which I am using. And as and how I go for adjoint of a matrix, then I am going to start many properties. Okay, that will be serve as a shortcut for us. Question number 6 says a matrix A of order 3 by 3 has a determinant 5. So write down this statement in mathematics language. There is a matrix A whose determinant is 5. So determinant of A is 5 and the order is 3 by 3. And if I take n to be order of the matrix A, then n is 3. Okay, because they said 3 by 3. And we know no, as soon as a square matrix, we won't say 3 by 3. It's only one number is enough. So I won't write n cross n. It's only n. What is the value of determinant of 3 times of A? See, we have one property. What? Determinant of k into A, where k is a scalar and A is a matrix. This is equal to k power n into determinant of A, where n is order of matrix A. Order of matrix A. I wrote 2 below. Oh, yeah, it's visible. Now, in place of k, we have 3. So, 3 out. Power n. N is 3 into determinant of A. How much is 3 power 3? 3 3s are 9, 9 3s are 27. Into determinant of A given is 5. Multiply this. 5 7s are 35. 5 2s are 10. 10 plus 3 is 1. Okay, 10 plus 3 is 39. I mean to say 135. Option A is correct. Job done. Okay. And see, you cannot escape from the properties. You have to be perfect. Now moving on to next. As in I'm taking the problem, I'm trying to resolve the properties. If question number 7, question number 7 says if A is this matrix and determinant of A power 3 is 343, then find the value of x. See, surely many students will think that multiply matrix A thrice and then find the determinant and then equate to 343 and get the answer. Time consuming it is. Here I am going to quote one important property that determinant of A power n is same as determinant of A whole power n. Now here n is the power of matrix A, not the order. Okay. So always no, either you can multiply A n times and then take the determinant, or take the determinant and then raise the power. Both are same. So this one we can rewrite as determinant of A whole power 3 is equal to 343. Now determinant of A, come on from here, plus minus. So if I expand, now we should be able to directly expand. Okay. So how to go about? X into x, x square, then minus 2 2s are 4. The whole cube is equal to 343. Now here when we are going to simplify, don't forget you have to solve for x. Don't expand by using a minus b whole cube. You can take cube root on both the side. Taking cube root on both the side, we get x squared minus 4 is equal to 343 cube root. No use of calculator. Cube root of 343 is 7. So x square minus 4 is equal to 7. Solve for x. So transpose this, we will get x square is equal to 4 plus 7. 4 plus 7 is 11. Or x is equal to plus or minus root 11. Plus or minus root 11 is then option blue. So option blue is correct. I hope this is clear. Yes. Now let us move on to the next question. Question number 8. If A is a square matrix of order 3. So order of the matrix is 3. Determinant of A is 5. Find the value of determinant of 2 times of A transpose. See, transpose of a given matrix is again a matrix. Now when I am going to apply the same property here, this property I am going to apply what? Determinant of K into matrix A is K power n into determinant of A, where K is any real number. K is any real number. I write it here also, K is any real number. Now in place of K we have 2. So 2 times of power n, n is 3. And see this, whichever matrix is the same matrix is there here. So here it is matrix with a transpose. But we also know one more property. What? Transpose of the determinant and the given determinant both are same. So I can rewrite 2 cubed is 8. This is same as determinant of A only. What is determinant of A? 5. So 8 into 5 is 40. 40 is there in option D. So option D is correct for question number 8. Some students will be thinking, is it true, sir? Very simple. See, take one matrix of order 2 by 2 just to make you understand that this property is true. So if I say determinant, if I talk about A, B, C, D, plus and minus, multiply this, A into D, AD minus B into C. This is determinant of A. If I take transpose of this, the first row AB will go to first column for a while. Let us give the determinant symbol here. So AB will be the first column, CD will be the second column. Now expand this. A into D will be AD minus B into C is BC. You can see you got both. That's what I'm saying. For any order, not only for order 2 or 3, for any order, determinant of A and its transpose is always equal. Okay, that A power T, or just if I give A dash, both stand for what? Transpose of a given matrix. For a while. Fine. Let's proceed with question number 9. If A and B are square matrices, each of the order 3. Okay. The order of both the matrix order is what? 3. And determinant of A, B is given, then the value of this we have to find. Determinant of A is given to be 5, determinant of B is given to be 3. We have to find determinant of 3 times of AB. Now be careful here. When you're talking about this, A into B is product of 2 matrices. Ultimately, after multiplication, we'll get one single matrix. So what I'm trying to convey is K times of matrix A is equal to K power n into determinant of A. So this is a matrix. Yeah, A and B is a matrix. In place of scalar K, which is a real number, we have 3. So when I take it out, it will be 3 power what? N. N is 3 into determinant of the matrix AB. We also know that determinant of A into B is same as determinant of A into determinant of B. So I can just 3 cube is 27. That is the determinant of A into determinant of B. So we'll get 27 times of determinant of A is 5. Determinant of B is 3. So multiplication 5 is a 15. So we will have 27 into 5 3 is a 15. If you multiply this, 5 7s are 35, 5 2s are 10, 11 12 13. See, unit place is 5. Yeah, this is the answer, because in none of the option unit digit is 5. But anyway, let's complete the multiplication. 1 into 7 is 7, then 1 into 2 is 2. So the answer will be 504. So 405 is the answer, option A. I repeat, the answer of this is what? 405. That is there in option A. I hope this is clear. Kindly make a note. So dear students, proceeding with the next problem. Question number 10. If A and B are square matrices of the same order 3, such that determinant of A is 2 and A into B is 2 times of identity matrix, then write the value of determinant of B. So coming to the data, A into B is 2 times of identity matrix. Now since I want determinant is given here and I want determinant value, so I'll take determinant both the sides. Determinant of AB is equal to 2 times of determinant of 2 times of identity matrix. As we know that determinant of A into B same as determinant of A into determinant of B. Now coming to this, we already know that determinant of K into any matrix is K power N into determinant of A, where N is the order of the matrix A. Correct? What is N? Order of matrix A in this formula. Now here 2 is a scalar here. K is any real number, as you are aware. So 2 is a scalar, so 2 will be out, and power will be order of the matrix A. Now see, here I order is not given, but don't forget, since we are dealing with determinants, it should be a square matrix and A and B of order 3. Since A and B is of order 3, the product will be also of order 3. Therefore, this identity matrix order should be 3 only. I hope this is clear. Since A and B are square matrix of order 3 by 3. Let's write it again here. A is 3 cross 3, correct? B is also 3 cross 3. And here it's the product of 2 matrices. Whenever we multiply 2 matrices, the product after I multiply, first this number of column of the first matrix should be equal to number of row of the second matrix. After we multiply, the order should be 3 by 3. This number of row of the first matrix and number of column of the second matrix. So because of this itself, I am saying that identity matrix will be of order 3 by 3. Okay. Now since order, see whichever scalar is there, this matrix power, this matrix order power is here. So since I is of order 3, so power will be 3 here into determinant of I. What is determinant of identity matrix? It's always equal to 1. You can compute yourself. How, sir? For example, 2 cross 2 if I take. What's the value of this? 1. Okay. Identity matrix of any order n will be, if I take the determinant, it will be always equal to 1. Okay. Now come here. Determinant of A is 2. Determinant of B I have to find. 2 cube is 8. Determinant of I is 1. 2 1s are 2 4s are. Therefore, determinant of B is equal to how much? 4. That is there in option blue. So determinant of B is 4. You can see the problem which I have selected. Without properties, you can't do anything. You have to memorize the properties. Before taking 11th question, let us take this 12th question. If A is a skew symmetric matrix of order 3, then the value of determinant of A is, they are asking you to find determinant of A if A is a skew symmetric matrix. Solution. See, question is given that A is a skew symmetric matrix and of order 3. Now, what I am going to justify, no, it's not only for order 3. 3 is an odd number, no. So, whenever the order is odd, the result will be always true, what I'm going to discuss. So whenever you see determinant and A is a skew symmetric matrix of order odd, the value which I'm going to get will be always true. Now let us try to solve this problem in place of order 3 for any odd order. Okay. So now see, determinant of A I want to find. First, before we start this, since A is a skew symmetric, is it not? A transpose should be equal to minus A. Now I want determinant, so I'll take determinant on either side. Now we know the determinant of A transpose is determinant of A itself. And having the same rule, scalar and a matrix A. So I'll apply the same thing here. Recall determinant of K into matrix A is K power n into determinant of A, where n is the order of the matrix. Now in place of K we have minus 1 here. So we are going to have minus 1 power n into determinant of A, and this determinant of A transpose is equal to determinant of A itself. This is transpose. Okay. Now since n, I said order is odd, so n is odd here. So since n is odd, whenever base is negative, power is odd, I'll get negative back. Then determinant of A. Now transpose this. Minus will become plus A, so I'll get 2 times of determinant of A is equal to 0. Cross multiply 2. So this implies determinant of A is 0. A very, very important point I've highlighted, that whenever you have got any skew symmetric matrix and the order is odd, not only 3, odd. When I say odd, the order can be 1, 3, 5, 7, odd numbers. Always the skew symmetric determinant is always 0. That is in option blue. Okay, option B is correct. Now I want to highlight one more point here. Sir, you have commented about skew symmetric of order odd. What about skew symmetric of order even? Let us have a note here. If A is a skew symmetric matrix of even order. I'll take one example. Ordered, not ordered, order. One example I'll take where it is a skew symmetric and the order is 2. So for example, 0, 0, as you know, for skew symmetric, diagonal element should be 0. And if I take here 3, I should have here minus 3. Okay, now expand this. 0 into 0 is 0, minus to minus is plus, 3 3s are 9. Okay, we are going to get perfect square number. Perfect square number whenever we take determinant of skew symmetric matrix of even order. You may think by chance we got. So if I take a general example for you, determinant of, again this will be 0. So here it is a plus A here, then it is a minus A here. Now come on, expand this, plus minus 0 into 0, 0, minus to minus, plus A into A square. You can see a perfect square number. Okay. So always we'll get a perfect square number whenever it is of even order. For odd order, we'll get always 0 for a skew symmetric determinant. Okay, I hope this is clear. Now here we have got some PUC question which we have got for 3 marker. I thought why not, we'll take this also. It should not happen that no, you practice everything and you forgot this one and we lost the marks. Let us first erase this, kindly make a note. Dear students, let us continue with the next problem. And both are PUC problem there. Find the area of the triangle whose vertices are given by this. So recall, let us take the solution this side. Solution here. So since there are 3 vertices given, the first vertices is x1, y1, second one is x2, y2, and the third one is here x3, y3. Don't forget area of triangle. Let us say ABC, where this, assume this is A, then this is B, and this vertices is C, is given by half of determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. So if I substitute here, half of, yeah, x1 minus 2, then y1 6, then 1 here, then here 2 minus 6, 1, and lastly 2 minus 5, 1. Now we can expand plus minus plus. So half of bracket plus into minus is minus 2. Leave this one column. So multiply. Leave this one column. Remaining is minus 6, 1, minus 5, 1. Then minus 6 here. Again, leave this one column. You'll get 2, 1, 2, 1. Okay. Then plus 1 times of. Leave the first row and the third column. So we'll get 2 minus 6. Then 2 minus 5. So plus minus, plus minus, plus minus, recheck. Have written correctly all the things? Yes. Now the answer will be half of minus 2 times of cross multiply. Minus into plus is minus, minus 6 here. Then minus minus plus, 1 5 is 5. Then minus 6 times of 2 1s are 2, minus 2. So 2 minus 2. Then plus 1 times of 2 into minus 5 is minus 10. Then minus minus plus 2 6 are 12. So here you get minus 10 plus 12 will be 2. 2 minus 2 is 0 here. Minus 6 plus 5 will be minus 1. Minus 1 is plus. So half of 2 1s are 2 and here plus 2. 2 plus 2 is 4. 2 and 2 1s are 2 2s. So answer is 2 square units. Option D is correct. Option D is correct. Now, first make a note of this. I'm going to this. Okay. Now, moving on to this was solution for 11th problem. Now, moving on to question number 13. Don't forget, before I go ahead, I would like to comment some of the things here from this area of triangle. Don't forget, let us suppose that if area is negative, we are going to take mod. So, note number 1, if evaluation of this part, see, area of triangle we are saying, if we are getting this part to be evaluation of half of determinant of x1 y1 1 x2 y2 1 x3 y3 1 is negative, then take modulus, as area cannot be negative. Area cannot be negative, right? And whenever you talk about coming this problem, okay, let us first solve this problem, then I'll give some more comment there. So coming to 13th solution, now I'm talking about 13th solution. If the area of the triangle ABC with vertices A, B and C is 9 square units, then find the value of K. So whenever area is given, so here the area is given to be 9. So here area of the triangle is 9 is equal to, so again the first vertices A we can take as x1, y1. Second vertices B we can take as x2, y2. And the third vertices is x3, y3. So if you substitute here half as it is, so x1, y1, so it is 1, 3. Then for by 1, x2, y2, 0, 0. And then K, 0, 1. See, now here we have a vertices. One of the coordinate of the third vertices is not known. Whenever we are going to find this, don't forget, we'll take either we want plus or minus. We want both those K value, which is giving positive as well as negative. Actually, this K we get two values depending on clockwise or anti-clockwise orientation of the vertices. Okay, fine. Now just cross multiply. 2 9s are 18. And when I want to evaluate, now see, maximum number of zeros are there in which row? Second row. So as I said, remember this diamond sign. Now since I want to expanding along second row R2, so here the sign, see, minus, so only this sign I have to consider. This sign I have just given. If it is first row, plus minus plus, second row, minus plus minus, third row, what? Plus minus plus. So we column also, correct? Now When I have not mentioned the sign, what's the meaning? It is plus. Correct? So now since I want to expand along second row, here minus of 0, then plus of 0. I am not writing any multiple here because 0 and a number is what? 0. Then here, don't forget, plus, minus, plus, minus. So here, minus 1 times of, leave this row and column. We are going to be left with 1, 3, K, 0. So simplify now. Plus or minus 18. This is anyway gone. So here minus 1 times of 1 into 0 is 0 minus, yeah, it is plus minus 3K. Now from here minus is plus, so plus or minus 18 is equal to 3K. 3 ones are 3 6 are. Therefore K is equal to plus or minus 6. K is equal to plus or minus 6. Now here they have given only positive value plus 6, but both the values are right. Now here what is happening? Try to understand. Okay, first option D is correct for this, and for this 11th problem again was option D only was correct. Here minus 6 means that even when I talk about negative, also negative area, you said negative area cannot be negative, but we are talking about negative area. Actually what's happening, let us just try to plot the diagram for you to make it very clear. 1, 3. So here there's a 1 here, 2 here, 3 here, minus 1 here, 1 here, 2. 1, 3. So 1, 3. Okay, here. So 1, 3. This is your vertices here. Then 0, 0. This is B. 0, 0. Okay. Now K. First I'll take K, positive value, 6, 0. 6, 0 will be somewhere here, 6. Okay. Here it is 4 and here it is 5. 6, 0, coordinate C. Now let us join this. Let us join this triangle. Now see, I will just again, no, let us just focus the what traces. It is what? A, B, C. See the order. A, then what? I am going to B, then going to what? C. I am going anti-clockwise, due to which the rotation, since this is anti-clockwise, it is what? Positive. So it is positive area. We are getting a positive value. I mean, I am getting a positive value because orientation is what? Anti-clockwise. Anti-clockwise is always positive, don't forget. Okay. Now see, if I take this negative value, don't forget A and B both are same, correct? No. So now minus 6, 0, minus 6, 0, minus 6, 0, somewhere here. So this will be minus 1 here, then minus 2, minus 3. So minus 2, like that. This will be minus 6, 0. K, 0, no. Now this I'll take as some C dash. Now join this triangle. Join this triangle. I want again what? A, B, C. So A is here, B is here. Now join this. Now come on, go for the orientation of this A, B, C, correct? So I have to go from A, then write as this. Okay, write as this for you. Now see, I have to go from where to where? A, B, C, correct? No, A, B, C dash. Okay, A here, then B, and then C. See the orientation. It is what? Clockwise. Clockwise is always what? Negative direction. Both the area, if you remember application of integrals, where we have discussed that whenever any area is there above x-axis, it's always positive. But here both are lying above x-axis, but then also one is positive, other is negative. Reason is, when I went for measuring the area, means when I went for the vertices, I went clockwise. Since I went for clockwise, I have got negative. And since here we went for A, B, C, it is anti-clockwise, we got positive. Similarly, let us suppose no, we change the order. A, if I take this as B and then C, nothing but this A, then B, then C. 6, 0, which is there, no. 6, 0, which is there, no. If I take this as A, C, B. Okay, A, C, B if I take. Now it will be what? Clockwise. Again, for that also get negative. So this positive, negative, no, just because of the sense of rotation. I hope this point is clear. Doesn't mean we are saying that whenever the value is negative, take this mod, and whenever you want to find the area, plus or minus. Okay, because we want both this triangle is giving us area to be 9 square units. I hope this point is clear. So you are not going to neglect minus 6. Both are correct. In that, minus 6 is not given. No problem. Kindly make it out. Before I forget, one more thing I want you to understand is, if let us suppose on evaluation you got 0. If we'll take this as equation number 1. Note number 2, if area of triangle, I will let this area of triangle ABC is equal to 0. This implies the points, which points? A, B and C are collinear. Points, nothing but they are lying on the same line. Okay, fine. So the same points of PUC only I have taken. Now let us move on next. Kindly make a note. Yes, dear students, having understood and solving the problems on the basics along with the properties of determinants, now let us move on to the next concept, that is minors and cofactors. So let's recall this concept, cofactors. Yeah, and then we are going to take up the problems. Okay, listen carefully. Concepts are important. Concepts are basic. These are the one which is going to make us solve the problem, understand the problem, how to solve as well. So never neglect the concept. Okay, let's try to go a bit faster. Now, what is minor of a given determinant? Yeah, it is of a determinant. Now, if I talk about a determinant, let's suppose A, B, C, D. So now what is minor of the element A? The element A is a location of A11. So minor of A11 is a determinant obtained by deleting the row and column where this element A is present. This element A is present in first row and first column. First row and first column. If I delete that, if I delete the row and column where it is present, it means D. So the minor is D. So minor of A11, small a, is capital M11, which is equal to D. Capital M stands for minor, and this stands for the location of which element we are finding. Similarly, minor of the element B, B location is what? First row, second column, A12. So delete the row and column where B is present. It is in first row, second column. So this will be the minor. Okay, is M12 is equal to C. Actually speaking, no. As soon as I am removing the row and the column, actually I am getting determinant of order 1. This is determinant of order 2 cross 2. This is of 1 cross 1. As we learned at the beginning, the determinant of 1 cross 1 is the same element present. Here also it is a determinant of order 1 cross 1, and we have got the same element present. Like the remaining also we can find. Now comes cofactors. What is cofactors? Cofactors are denoted by capital Aij, sometimes even capital Cij. Okay, is equal to minus 1 power I plus j, because I did I properly, into Mij, where Mij is minor of the element Aij. Okay, so here coming to cofactor, a factor is multiplied, that is minus 1 power I plus j to the minor. Okay, and as you can see, this power is the index of the cofactor Aij. So cofactor, so minor are given by Mij and cofactors are given by capital Aij, or sometimes they can also be given as Cij. So you will have both the notation. And here the power is sum of the index. Okay. Now, for example, the same determinant, if I go ahead, so cofactor of, okay, so minus we are finding now. So cofactor of small a, the location is A11, is capital A11. Now just put whatever the formula is, just we are going to put the I and j value. In place of I we have 1, in place of j also we have 1. So put here we get minus 1 power 1 plus 1 into M11. 1 plus 1 is 2. So minus 1 power 2. M11, it's a minor which I already got D. Minus 1 whole power 2 is 1 into D is D. Similarly, cofactor of the element B is equal to the allocation of this is first one, second column. A12 is capital A12, which is equal to minus 1 power 1 plus 2 into M12. 1 plus 2 will be 3, so minus 1 power 3, and M12, yeah, minor is C. So this time minus 1 power 3 is negative C I will get. So the cofactor will just going to give a multiple, either plus 1 or minus 1, a multiple. And it completely depends on the power. If the power, sum of the index, whichever is there here for index of capital A, if the sum of the index is even, it will give you positive. Nothing but the minor will remain the same. I mean to say cofactor will remain same as a minor if sum of the power is even. If sum of the power is odd, then there will be a negative sign multiplied to the minor. It means that the original minus sign will change. As you can see here, minor of small a11 is D, cofactor also D. Why? Sum of the power is even. As you can see now, 1 plus 1, 2. But coming to 1, 2, since 1 plus 2 is 3, so you see minor we got C, but cofactor we got minus C, because sum of the power 1 plus 2 of the index is what? Odd here. Okay. Now this will be very helpful for us in having some more things there, like finding the inverse, etc. Now let us proceed. I hope first the thing is you have understood about how are we going to find the minor and cofactor. Now having this, let's try to take some problems on this first. And again I'm saying that, as I said, no, first I was thinking that you can refer to the PUC crash course which I've already uploaded, but it may be too time consuming. So what I'm doing is synopsis and the problem then and there itself, so that there's nothing for you to go back to the videos. Okay, fine. But surely I'm not going to do derivations, only synopsis I'm going to give. Okay, in case you want the derivation which is not required, you can always refer the PUC video. Okay, and link is shared in the description. Now let's take the problems. First, make a note of this. Okay, dear students, now let us move on to the next question. Recording, no? Yeah. Find the minor of the element of third row and second column in the following determinant. So our 3 cross 3 determinant I have taken. I want a minor of element of third row. Third row. See, element of third row and second column. This is third row, second column. Yes, this is the element. Third row, second column. So I want minor solution. Oh, where is the black? There. So minor of 5, whose location is third row and second column, A32 is M32. Delete the row and column. So remaining is what? 2, 5, 6, 4. Before I proceed, now that I hope it's very clear, I said you that when I wrote for minor for 2 cross 2 determinant, I said this is a 1 cross 1 determinant. Now it's very clear here. We might have thought, why to write this one? That we can write like this. Now you can see here 3 cross 3 determinant is reduced to 2 cross 2 determinant. Now simplify this. S minus 2 4s are 8 minus 6 5s are 30. 8 minus 30 is minus 22. Option C, Chalu, is correct. Okay. Now from this one, purposefully I've taken a question number 15, where this is going to talk about one important remark. What? Minor of an element of a determinant of order n more than 1 is a determinant of order. They're asking, if you take a minor for a given determinant, what is the order of that obtained determinant? As you can see, the order was 2. I got a determinant of order 1. The minor was 1. Here the determinant is 3 cross 3 and the minor is 2 cross 2. So always whatever the order we have got, minor is just 1 less than that. So here minor of an element of determinant of order n will be a determinant of order just 1 less than this. That is n minus 1. As you can see, order 2 minor is 1 and order 3 minor is 2. But here I would like you to, okay, option C is correct, but here I want to understand why it is n more than 1 they have specified. See, if I take a determinant of order 1 cross 1 and I want to find the minor, not possible, because as soon as I delete the row and column where 1 is present, nothing is available. Nothing is available. Therefore, to find the minor, the order should be minimum 2 of the given determinant. That's what n should be more than 1. Okay. I hope this is clear. Kindly make a note. So for 1 cross 1, we cannot find the I mean to say minor. When we cannot find the minor, there is no question about finding what? Cofactors. And even for cofactor also same question can be asked, what could be the determinant? Again it will be what? N minus 1 only, because you can see here, no? Fine. Kindly make a note. Okay, dear students, now let us move on to the next problem. Question number 16. If small cij is the cofactor of an element aij, the small letter, of the determinant given here, then write the value of a32 into c32. That's what I said, no? aij or cij can be standing for capital Aij or Cij for cofactors. Anyway, they have said themselves. And they said element, aij is the element. So a32. When I say a32, it is third row, second column element. Third row, second column, oh, this one, 5, into C32. So how to write cofactors? Recall, how to write cofactors? Cij is equal to minus 1 power I plus j into mij. So it is not nothing but here into minus 1 power, whatever index is, just sum them up. Index is 3 and 2, sum them up. Into m, whatever index is the same index, 3, 2. So 3 plus 2 is 5. So minus 1 power 5, 3, 2. So leave the third row, second column. So remaining will be 2, 5, 6, 4. So we get 5 times of minus 1 power 5 will be minus 1. I can simplify this. 2 4s are 8 minus 5 6 are 30. So 5 into minus 1 is minus 5. 8 minus 30 is minus 22. Minus minus plus. 5 into 2 is 10. Borrow 1. 5 into 10. 5 into 2 is 10. 10 plus 1, 11. So plus 110. Option A is correct. See how close the options are given. If we forget that we should have a factor minus 1 power I plus j, and just if you wrote minor, gone case, and the two here getting a negative value out. So we have to be extra careful. Now I just want to discuss one more point here, that whenever we are going to multiply a given element with its own cofactors along the rows, what is going to happen? Nothing but the value of determinant we are going to get. Let us try to understand. I'll take the same example here. Let us take as a note. See carefully. Let us take the determinant again here. This in detail I discussed in PUC, but again just a very quick recap we can have. Now see, at the beginning of this determinant chapter, I just gave you this diamond. I said here minus, here minus, here minus, here minus. Whenever you want to expand 3 cross 3 determinant. Now why that minus is coming, we are going to write the answer from here. Now for example, I want to expand along first row. For first row, what we write here, plus, then minus, then plus, correct? Why do we write that? First let us expand, then we'll understand the reason, okay? So plus 2. So leave this row, first row and first row and first column. So what we'll get? 0, 4, 5, minus 7. Then minus minus is plus 3. And leave the first row and second column, 6, 4, 1, minus 7. 6, 4, 1, minus 7. Then plus into plus is plus 5. Leave the first row and the third column, 6, 0, 1, 5. Now expand, plus minus, plus minus, plus minus. So what we are going to have, 2 times of 0 into minus 7 is minus 0. Then minus 5 4s are 20. Then plus 3 times of plus into minus is minus, 6 7s are 6 6 I say 42 will get. Then minus 4 1s are 4. Then plus 5 times of 6 5s are 30 minus 0. Then here 30 we have, and here minus 46 here, and then here minus 20. So we are going to have this, I'll take as delta. So delta is equal to minus, plus into minus is minus, 2 into 20 is 40, plus into minus minus, 3 6 are 18, borrow 1, 3 4 are 12, 12 plus 1 13, and here 5 3 are 15. So how much we are going to get? This will be yeah, let's write it here. 4 5 6 7 minus 178 plus 150 will get 6 7. Okay, minus 28 is the value of the determinant. I've just expanded along first row without applying any cofactors logic. Now let us again the same determinant, I'll take as delta 1. Now we will not change, now we will not change the sign plus minus plus. We try to understand the logic behind what's happening. See carefully. I want to expand this along first row. So expanding along first row by using the cofactors concept. So see, 2 is there. What is the cofactor of 2? The location of 2 is first row, first column. So cofactor will be capital A11. Then minus 3. Be careful. I'm not writing this plus 3 now. Minus minus plus. I'm not using that. I want you to understand the reason behind this. So minus 3. Leave the first row and second column. So what I'll get? So I mean to say minus 3. Minus 3 cofactor is what? It is present in first row and second column. So it is 1 2. Then plus 5. Plus 5 is present in first row, third column. First row, third column. Okay. Now don't forget the cofactors. Whether it's small aij or capital Aij, both are same. Both are same. So having this logic, now here in place of ij we have 1 1. So just put there 2 times of, yeah, here minus 1 power 1 plus 1 into m 1 1. Then minus 3 minus 1 times of 1 plus 2 m 1 2 plus 5 minus 1 power 1 plus 3 m 1 3. Now 2 times of 1 plus 1 2, so minus 1 power 2. What is m 1 1? M 1 1, it's a minor. I have to find the minor of the element present in the location of 1 1. First row, first column. First row, first column is 2. So leave this row and column. The minor of this 2 first row, first column will be this element, which is at 0 4 5 minus 7. 0 4 5 minus 7. I hope it's recording. Yeah. Then minus 3. 1 plus 2 is 3. So minus 1 power 3. 1 2. I want the element present in the first row and second column. First row, second column. See, first row, second column. This is the first row and this is the second column. So leave the row and column where it is present, that is minus 3. So it is 6 4 1 minus 7. So 6 4 1 minus 7. Then plus 5. 1 plus 3 will be 4. So minus 1 power 4. 1 3. Leave the first row and what? Third column. So when I leave the first row and third column, remaining is 6 0 1 5. 6 0 1 5. Now simplify it. 2 into minus 1 whole square is 1. Plus minus 0 into minus 7 is minus 0. Then minus 4 5s are 20. Then minus 3. Minus 1 power 3 will be minus 1. Then again plus minus 6 into minus 4 will be how much? 6 into minus 7, I mean to say minus 42. Then minus 4. Then minus 1 power 4 is 1. 1 into 5 is plus 5. Again plus minus 6 into 5 is 30. Minus 0 into 1 is 0. See carefully. 2 into 1 2 here. Then this is minus 20. Minus minus plus 3. Minus 42 and minus 4 is minus 46. Then plus 5 into 30. Now see carefully here. 2 times of, yeah, 2 no, minus 1 the whole square is 1. 1 into 2 is 2 and you got the same here. Minus to minus will be plus and you got the same here. Then minus 1 power 4 is 1. 1 into 5 is 5. Again you got the same. What I mean to say is, I'm trying to just give you the reason why it is plus minus plus. Okay, it is just that cofactors have got the sign minus 1 power I plus j. Whenever the index sum, if I take, if it is odd, I'm getting negative. If it is even, I'm getting positive. Okay. Multiply this, plus into minus minus, this is 40, then this will be 3 into 6 is 18, 3 4 are 12, and then 13, then 5 3s are 15. Anyway, we have got the same number present here, so we, since numbers are same, on simplification you get minus 28, nothing but delta 1 and delta both are same. Delta is this. Okay. Now one more thing, what I just want to again comment is, see carefully, as soon as I take any determinant of 3 by 3, see the element. I want you to understand the reason why I gave this minus, 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 and minus diamond. See here, A11, A12, A13. I'm adding the location of the element. Then second row first column, second row second column, second row third column. Then here, third row first column, third row second column, third row third column. Now try to just sum the index. And don't forget that after you sum the index, the cofactor, this minus 1 power I plus j, the completely, the whether it's negative 1 or positive 1 depends on the power. If it is even power, it is positive. If it is odd, it is a minus 1. So here ij, 1 plus 1, 2, 2. So this multiple is positive. Then 1 plus 2, 3. Right? In place of 1 and ij, it is 1 and 2, correct? So 1 plus 2, 3, minus 1 power 3 is negative, so negative when you expand along first row. 1 plus 3 is 4, 4 plus minus 1 power 4 is positive, 1. Okay, similarly if you go for this. So if you expand, before I go ahead, when you expand along first row, because of this then we give plus minus plus. Coming to second row, what is this? 2 and 1, 2 plus 1, 3, put here, 2 plus 1, 3. Minus 1 power 3 is negative. So along second row, this will be negative. Again, 2 plus 2, 4. Minus 1 power 4 is positive. Then 2 plus 3, 5. Minus 1 power 5, negative. So along second row, when you expand, it is minus plus minus. Okay. The way we take it here, for second row should be minus plus minus. That's what I gave you here. Minus and plus here. Whenever sign is not mentioned, it is understood that it is positive. Next, you see this. 3 plus 1, 4, minus 1 power 4, positive. Third row, if you think of expanding, then 3, 2, 3, this is 2, mind it. Let us write a bit more perfectly this. What is 3 plus 2? 5. Minus 1 power 5, negative I will get. So minus. 3 plus 3, 6. 6 minus 1 power 6 is positive. So when you go along third row, plus minus plus, that's what I gave you here. Negative, nothing but here and here the element is positive. We are going to give positive sign to multiply. And similarly along first column, you see the same sign can be written, the diamond sign. Now you can see now if I just give diamond like this, then here, then here, then here, this minus will go for this, and these two minus are going for the second row, and this minus is going for the middle term of the third row. Now if you go for first column, plus minus plus, second column minus plus minus, third column plus minus plus. Diamond sign. Okay, I hope this point is clear. So a given determinant can be expanded along 3 rows and 3 columns. Totally 6 ways we can expand, and whenever we are going to multiply the elements of a row with its cofactor and add them, and what, add them, then we get value of the determinant, then we get value of the determinant. Let us take for one more case. Let I erase this. Kindly make first. Kindly make it out. Okay, dear students, same determinant. This is my equation number 1, and I got this value delta 1 is equal to delta from equation number 1. Now let us try to multiply delta 2. I'll do one thing. Here writing expanding along first row is ideal. Expanding along first row R1, and here interesting expanding best is multiplying first row elements. This is very ideal. Yeah, first row elements with its cofactors. That's what we did now. We have multiplied the first row element with its own cofactors. Now let us do one thing. Let's go for column. Okay. Delta 2 I will take. Same determinant 2 minus 3, 5, 6, 0, 4, 1, 5 minus 7. This time, no, I'll try to go for second column because I got 0 here. I can have some easy simplification. Okay. So multiplying. So in these two things we get over. I can also look for column cofactors, multiplying column element with its cofactors. And advantage of this is wherever you can see a 0, we can expand along that to our column so that we can reduce the computation. So multiplying second column elements with its cofactors. Now see, this is my second column. So delta 2 is equal to, and I'll do one thing, no, I want you to have still more clarity. Just see there, just see here. 2 location is A11. So A11 space is there. Okay, I'll write it here. 2 is what? Present in first row, first column. Then cofactor. Next, minus 3 is there in first row, second column. And then it's cofactor. Then 5 is there in first row, third column. There is a reason why vertex like this. Okay, subber. Now here, this location is first row, second column, and its cofactors are what? This is there in what? Second row, second column. So plus second row, second column. Then this is there in third row, second column. Element I forgot. First element I want, and I am multiplying its cofactor only, so there is no change in the index of cofactors. Now A12 is this element, first row, second column, minus 3, and the cofactor we know minus 1 power 1 plus 2 and the minor m12, correct? Then A22 second row, second column 0. When it is 0 into anything is what? 0. So why to write? Just I write as it is, and this is anyway gone, 0. A32 third row, second column 5. So this will be minus 1 power 3 plus 2 into M32. Now minus 3, 1 plus 2 is 3, so I'll get minus 1 power 3. First row, second column, I hope it's visible properly. First row, second column, nothing wrong. I just wrote again. First row, second column. Yeah, first row, second column. We are going to be left with 6, 4, 1 minus 7. Then plus 5 minus 1 power 3 plus 2 is 5. Third row, second column. We are left with 2, 5, 6, 4. Now expand this. Plus minus. Minus 1 power 3 is minus 1, minus is plus 3. Plus into minus. 6 7s are 42. Minus 4 1s are 4. Then plus 5, minus 1 power 5 is minus 1. 2 into 4, 8, minus 6 5s are 30. Minus 42 minus 4 is minus 46. And 8 minus 30 will be minus 22. So plus into minus is minus. 3 6s are 18. 3 4s are 12, 13. Then plus into minus is minus. Minus to minus is plus. 5 into 10. 5 into 22. 5 2s are 10. Again 5 to 10, borrow 1, 11. Simplify, will get minus what? 28. Yeah, minus 28. Yes. What we have understood? We have understood that whenever we multiply an element with its own cofactor, I repeat, whenever a row element here, row elements are multiplied with its own cofactors and simplified, we get value of the determinant. Not only that, even among column also. Here I have taken second column and multiplied by second column cofactors, and I've got value of the determinant. Sir, how to know? Just by seeing that it is which column element and which column cofactor. Very simple. Don't forget, in the chapter matrices we have discussed that whenever we have Aij, the first index I stands for row and the second index J stands for what? Columns. So coming to this, see which index is same throughout. Here if you see 1 1 is there, 1 2 is there, and 1 3. Oh, first index is same. First index is same, and it's equal to what? 1. First index and for row, and since the first index is always 1, it's a first row. That's why you can see, no, 2 minus 3 5 are first row element. And you see the cofactors here also 1 1 1, whereas you can see the column is changing, correct? So again the row index is same, nothing but those are cofactors of first row. Come here. If you see the first index here 1, then here 2, here 3. First index are not same, not constant throughout. But if you see the second index, that is 2 here, again 2 here, and again 2 here. Oh, column is same because second index is always column and it's always 2. Okay, it is elements of second column. These are small letter A is elements, and of which column? Second column, second column, second column. Whereas capital A, if you see, again the first index is not same, whereas second index is same, 2 2 2. Okay, recording, no? 2 2 2. It is cofactors of second column. So elements are also second column. You can see 2 2 2, and columns also second. I repeat, elements are from second column. Even cofactors are also from the same second column. So whenever we multiply a row element with its own cofactor, similarly column element with its own cofactor, then we get value of the determinants. Okay. Whereas if you multiply any row with some other row cofactors, then we get the value to be 0, which is not the value of the determinant. Okay. So having this logic, let's try to take that one last one example on this, then we will start with the problems. See, here only I will take. For this only I will take. Just see carefully. After that, that will be a very important, this will be a very important result for us. Okay. Now see carefully. Now I am going to multiply a row with some other row cofactors. So let us multiply. I'll take second row now. Second row by either first row cofactor or second row factor. I repeat, either first row cofactor or third row cofactor. Don't go for second row cofactor because you will get surely value of the determinant minus 28 only. And so why you are taken second row? 0 is there, no? Easy calculation. By third row cofactors. Let us take this and see what's going to happen. So I'll take this as delta 3. Okay. See carefully. So I am planning to go with second row and cofactors are third row. So see this. This is there. A what? Second row, first column, and cofactors are third row. No. So A31. I mean to say A31, third row. No. Then plus A22, A32, then plus A23, capital A33. You can see very clearly for the element small letter A, 2 2 2, nothing but first row is, the row is 2, and see the cofactor, the first index 3 here, 3 here, 3 here, nothing but the cofactors are from third row. So A21, nothing but second row, first column 6. Then here this will be minus 1 power 3 plus 1, that is 4 here, into M31. Then plus A22, 0. 0 into anything is 0, so write the element. Then plus A23, nothing but A23, second row and third column, 4. And minus for this means cofactors of this is minus 1 power 3 plus 3, that is 6, M33. Now 6 times of minus 1 power 4 is 1. And so third row and which column? First column. So third row and first column, if I delete, remaining element is minus 3, 5, 0, 4. Then minus 1 power 6 is 1. 1 into 4 is 4. Third row, third column. Third row, third column, if I remove, the element is 2 minus 3, 6 0. 2 minus 3 6 0. Now simplify. 6 into 1 is 6. Then plus minus 3 into 4 is minus 12. Then minus 5 into 0 is 0. Then plus 4 times of plus minus 2 into 0 is 0. Minus is plus, cross multiplication. Minus plus 6 is the 18. Okay. Now simplify. What's the value? Plus into minus 6 to the 12. 6 to the 6, 72. Here also. 8 4 the 32. Borrow 3. 4 was the 4. 5 6 7. Yes. Plus 72 minus 72. What we are getting? 0. We are getting the value to be 0. Why we are getting the value to be 0? Understand? We have multiplied second row elements with the third row cofactors. That's what I'm stressing repeatedly. That whenever you are going to multiply a row elements with its cofactors, we will get value of the determinants as we saw in delta 1 and delta 2. Here I multiplied the first row element with its own cofactor, and in delta 2 I multiplied second column elements with its own cofactors. But as soon as I multiplied second row element with the third row cofactors, the value is 0, which is not the value of determinant. A very, very important point to be remembered. Okay. First, kindly make a note. Yes, dear students, what we have just understood, I have taken in the form of a note, which I want you to remember, that whenever we take sum of product of elements of any row with their corresponding cofactors, the value will be equal to determinant of A. When I'm taking row, I should take row cofactors, its row cofactors. If I take column, I should take its corresponding cofactors. Whereas, if I take a row and if I take some other row cofactors, I repeat again here, if I take first row, I have to take first row cofactors only. If I have taken third row, I should take third row cofactors only. Only then we'll get value of determinant. Similarly, if I take third column, I should take third column cofactors only. If I have taken first column, I should take first column cofactors only. Thus the reason very clearly we have used the word here corresponding cofactors. Only then we get value of determinant. Whereas whenever you are going to take sum of the product of any row with any other cofactor, row cofactors, then the value will be 0, which is not the value of determinant of A. We'll get some other value which we saw. Okay. So if I have taken first row elements and if I am multiplying with second row cofactors or third row cofactors, value will be definitely 0. Similarly, if I have taken second column elements and if I multiply with first column cofactors or third column cofactors, the value will be again 0, which is not the value of determinant. On that, I have taken one problem here. Question number 18 says, if delta is given by this, where capital Aij is cofactors of small aij, then the value of this delta, nothing but the value of this determinant is. And because of this problem itself, I just made you understand with respect to index how to know. Just see this. First, we'll concentrate on small letter a. Just see, as you know, first index in aij, the first index, right again here because I'm not confident that this is visible for you. So this stand for row, I stand for row, and J stand for columns. Now, see which index is same in small letter. 1. So this is first row elements. What about cofactors? You see 3. Oh, so first row elements are being multiplied by third row cofactors and they are summing up. Just multiplying not sufficient. When I say row are multiplied with cofactors, whether it is with the same row or some other row, when I say only multiply, it's only this. I have to say even sum also, I have to sum them up. And here first row elements are being multiplied with third row cofactors and then summed up. The value will not be the value of determinant. So option A is wrong, it will be 0. See the second option. Recording no? In the second option, see in small letter which index is same? Yeah, first index 1. So first row elements are there. And which index is same in capital letter? Second index 1. Second index stands for column. So the first row elements have been multiplied with first column cofactors. I repeat, first row element is been multiplied by first column elements. I repeat, first row element is multiplied by cofactors of first column. That will never give you the value of determinant. It will be some other value. Sometimes means 0, sometimes may not be 0. Okay. Option B is also out. Now you see here, which index is same small letter? 2, 2, 2. Okay. So the elements of second row. What about cofactors? Which index? 1. First index is same. First index is same. So it is row. First row, the 2, because 1, 1, 1. Correct now? So the second row is being multiplied by cofactors of first row. Again, the value will be 0, which is not the value of determinant. Option C is also out. Now you see the last one. Here you see which index is same, I or J, first or second. See this, 1 here, 1 here, 1 here. Okay, it is first column. So first column elements are taken. Next, coming to capital letter, which index is same? 1, then 1, 1. First column cofactors. So first row elements are being multiplied by first column cofactors, and this will give you value of the determinant A. Option D is correct. And coming to this type of question, now simple. See the index 1, 1, 1, 2, 1, 2, 1, 3, 1, 3, 1. They'll be same. Only then no row with its cofactor. Fine. I hope this point is clear. Kindly make a note. Okay. Yes. Now, dear students, let us move on to the next concept, that is adjoint of a matrix. Adjoint of a matrix. See, there should not be any confusion. Sir, which is a square matrix? As soon as this chapter determinants, whichever matrix we are discussing, all are square matrix only. Okay. What is adjoint of a given matrix? So adjoint of a, okay, let me make it very clear for you. Square matrix is transpose of cofactors. That is, if let us suppose, if I have got a matrix of 3 cross 3 whose elements are A11, A12, A13, then A21, A22, A23, then A31, A32, then A33. Okay. Then what is adjoint? In short, write A, D, J, and whichever matrix we are talking about, that matrix is written here. A, D, J stand for adjoint of the given matrix, which stands for transpose of cofactors. Take a transpose of what? Cofactors. What is the cofactor of small a11? It is capital A11. For this, capital A12. For this, capital A13. For small letter A21, it is capital A21. For this, it is capital A22. For this, it is capital A23. And this one is capital A31. Capital A32. And lastly, this is capital A33. And as soon as I take the transpose of that, we are going to have the first row will be here A11, A12, and then A13. Then A21, A22, A23, and lastly A31, A32, and A33. This is the adjoint of the matrix here. And most important, adjoint of a matrix is again a matrix only. Be careful. Adjoint of a matrix again a matrix. And what is the order of the matrix here? 3 by 3. Adjoint is also of order 3 by 3. Order also will not change. Okay. Now let us try to understand how are we going to take adjoint of order 2 cross 2, and then we can have a short formula for that. See, if I have been given matrix A is equal to 2 cross 2, that is A11, A12, A21 and A22, what will be the adjoint of this? Then the adjoint is what? Transpose of cofactors. So transpose of cofactors. Cofactor of this is capital A11. For this it is capital A12. For A21 it is capital A21, and lastly it is A22. And if I take transpose, the first row will become first column A11, A12, and the second row will become second column A21, A22. Whereas, like the cofactors, don't forget, it is capital Aij is equal to minus 1 power I plus j into Mij. So cofactors, capital letters, it is minus 1 power 1 plus 1 into M11, correct? No? So 1 plus 1 is 2, minus 1 power 2 is 1, and M11, leave the row and column where first element is 1. So leave this row and column, what will get? A22. So capital A11 is A22. That is here. Similarly, 2 is there. 2, 1, no? Come on. Mind calculation now. 2, 1. So if I put here 2 plus 1, 3. Minus I'll get. A21. Where is A21? Yeah, here. Second row, first column. I'll get A12. Correct? Again, 1 plus 2, 3. So minus 1 power 3 is negative. 1, 2. 1, 2. Yeah. Leave the first row, second column. What will you get? 2, 1. Correct? No? A12, nothing but leave the row and the column where the element is present. Element is present first row. You can see the index, first row and second column. First row is this, second column is this. This is the answer. A22. Leave the second row and second column, and here 2 plus 2. 2 plus 2 is 4. So I'll get positive. Second row, second column, if I leave, I'll get A11. Sir, I'm not able to follow, then you can do like this. This is the adjoint of the given matrix A. See carefully. For 2 cross 2, there is no need to find the cofactors individually and then take the transpose. Here directly you can get. How, sir? See carefully. Diagonal element, if you see, we have exchanged. And if you see non-diagonal elements, sign is not interchange, sign is changed. Interchange means what? This sign should go, this sign of A21 should go to A12 and A12 should come to A21. That has not happened. We have changed the sign. So sign of A12 is plus here, I have changed to minus. Sign of A21 is plus here, I have changed to minus. So let us write without index. So if matrix A is equal to A, B, C, D, then the adjoint of the matrix A is given by, we have to exchange the diagonal element or interchange what? Diagonal elements. So if I interchange the diagonal elements, D is here and A is here, and then change the sign of non-diagonal elements. So here I am not using the word now interchange, I am using the word the change the sign for the for C and D. Change the sign. Is this color visible? Change the sign. Yeah, fine. Change the sign. So sign of B is now going to be from plus B to, now it is minus B. And for plus C, it is now minus C. That's it. And one more thing. If I take the adjoint again, see again, take the adjoint of adjoint A. See carefully. Now I am taking adjoint of this. If I take the adjoint, as per the concept, what we have to do? Interchange the diagonal element. Now the diagonal elements are D and A. Interchange. If I interchange, I will get here A and then D. Then change the sign of non-diagonal elements. So minus B will change to plus B, minus C will change to plus C. Minus C will change to plus C, and this is Same as the given question, nothing but A. So whenever it is 2 cross 2, whenever it is 2 cross 2 matrix, double time if we take adjoint, we get back the matrix A itself. We get back the matrix A itself if we are going to take adjoint twice, provided the order of the matrix is 2. For order 3, it is not the case. We'll discuss shortly. I hope this point is clear. Fine, let us discuss some of the things here, then we'll take the problems. Kindly make a note. Okay, now dear students, having understood the concepts, now let us take some results, okay, and some definition. So starting with singular matrix, let I erase this heading also, adjoint of a matrix. Now, singular matrix, non-singular matrix, we'll discuss. See carefully. Singular matrix. A square matrix, yes, is said to be singular if its determinant is equal to 0. For example, if I take one matrix A whose elements are 1, 2, 3 and let us say 6 here. Now if I take the determinant of this, we get 1, 2, 3, 6 plus minus 1 into 6 is 6, then 2 into 3 is 6, 6 minus 6 is what? 0. This we call a singular matrix because its determinant is what? 0. Whereas non-singular matrix, it is a square matrix. A square matrix is said to be non-singular if its determinant is not equal to 0. For example, if I take one matrix B is equal to 1, 2, 3, 4. Find the determinant of this. What we get? 1, 2, 3, 4. Here plus and minus. 1 into 4 is 4. Minus 3 into 2 is 6. Answer is minus 2, which is not equal to 0. Okay. Now we are going to have some important results, and this all results will be very, very important for our problems as well. So let's take the I mean to say the results, important notes I can take as formula, and I would like, as I said, write all this in your one sheet of paper in the book better, so that you are going to memorize them, and this will be serving as a shortcut for us. First one, we talk about adjoint. Whenever we are going to multiply any matrix, square matrix A with adjoint of the given matrix, it is same as adjoint of A into A. Nothing but it's a commutative here. Special case matrix, I said it may be commutative. Yeah, it is here. And this is equal to determinant of A into I. Okay. So A into adjoint A, adjoint A into A will be determinant of A into I, and this will be a now scalar matrix. Okay. And one more case. If determinant of A is 0, then if scalar is 0, when scalar 0 is multiplied to any matrix, output is what? 0 only. So if determinant of A is 0, then it is 0 matrix. Two things can be noticed. Next, if we take determinant of adjoint of any matrix, it will be determinant of adjoint of any matrix, it will be determinant of A whole power n minus 1 whole power. Okay, I avoid the confusion for you. Let us give a bracket, okay, where n is order of the matrix A. Next, here I give only one time adjoint. Sir, what if I've got more number of adjoint? And before that, sir, what about adjoint of a matrix? For 2 cross 2, we came to know it is matrix A only, but for 3 cross it is not so. So the result will be determinant of A n minus 2 into matrix A, provided determinant of A is not equal to 0, nothing but it is not a singular matrix, it is non-singular matrix. And for 2 cross 2, we said adjoint of adjoint is A, and here n is the order of the matrix. For 2 cross 2, n is 2, correct now? So 2 minus 2 will be 0, and denominator, I mean to say base is not equal to 0, as we said, it's a non-singular. So since base is not equal to 0, 0 power any number, I mean to say base is non-zero, correct now? So since base is non-zero, determinant of a whole power 0, if n is equal to 2, this will be what? 1. 1 into a is what? A only. Okay. So this is true for any matrix of order 2 as well. Next, sir, what if I take a joint like this, I move on, and ultimately I'll stop somewhere here, and 1 2 3 1 2 3 1 2 3, and number of adjoint which we have taken here is r times, how many times? R times. And then I want to take the determinant of this. You know from PUC class, for 3 cross 3, how difficult, how lengthy it is to find the adjoint. 5 marker question. So there I can use this result. It is determinant of a whole power n minus 1 whole power r, where r stands for number of time adjoint repeated. And if you just see this and this 2 and 3, second is a special case of fourth result. R stands for number of time adjoint is there. How many times do we have adjoint? 1. In the left hand side, number of adjoint inside the determinant is r here. Here is only 1. So put r is equal to 1 here. We get back this result only. Okay. Next. Okay. Adjoint of A into B is same as adjoint of B into adjoint of A. The order will change, same like A into B whole transpose. Similarly, A into B, the whole inverse is same as B inverse into A inverse. Next, adjoint of scalar multiple with a matrix A. If the scalar is coming out, then we are going to have k power n minus 1 into adjoint of A, where n is order of the matrix A. Next. After this, yeah, adjoint of 0 matrix is 0. Adjoint of identity matrix is again identity. Not only that, if I multiply 0 matrix n time, I get 0 only. If I multiply identity matrix n time, I get the identity only. Okay. And what is the formula to find inverse of a square matrix? Anyway, solve a square. 1 by determinant of A into adjoint of A, where determinant of A is not equal to 0. And don't forget, we are going to have invertible matrix. I mean, say we are going to have inverse provided the matrix are non-singular. Inverse exists only if it is non-singular. Okay. We also have a theorem saying that invertible exists if and only if it is non-singular. This is invertible. Recall what is invertible? A square matrix A is said to be invertible if there exists a matrix B such that A into B is equal to B into A is equal to identity, where B is A power minus 1, nothing but B is inverse of A, which is not equal to 1 by A. It is not equal to 1 by A. I hope this is visible. Fine. First you make a note of this. It's not like a number, okay? It's just a notation. Just see, when I say no, B is inverse of A. Just see, B is inverse of A. See, B is inverse. This symbol inverse of what? A, square matrix A. Kindly make a note. Okay, and yeah, one more thing. Inverse of identity matrix is in the identity matrix itself. Nothing but I can say no. Same like invertible function. If f inverse is same as f, we call it is inverse of itself. So here identity matrix is inverse of itself. Okay, this will be an important point to remember. And coming to the scalar, we had somewhere here k. What is k? A scalar. When I'm saying scalar, it's a real number. We are going to have some more point. First, make a note. I'll just add some more point here. Yes, dear students, these are the remaining properties which I just want you to know. Let us try to make you understand this. See, if we are talking about inverse twice, we get back the same matrix. So if we remember this property, our working will be easier. Let us suppose they ask you to find inverse twice. In place of finding first time the inverse, you know how lengthy it is. But I'm going to teach you a shortcut also for that. And then again, you have to find the inverse second time. We are saying you'll get the same matrix A itself. We are taking the inverse on the scalar and matrix. Scalar and matrix both will get the effect of inverse. And since k is a number, a real number, non-zero real number, so when this inverse is taken for k, I'll get k power minus 1, which is 1 by k. This is happening because k is a real number other than 0. Okay. Then transpose and inverse can be exchanged. And this we know from the definition of invertible matrices. A into B, we say in place of B it is A inverse. Then if I take inverse, it will be changing the order, reversal rule. And it is also so for not only for 2, even if you have a 3 also, A, B, C is tends to C, B, A. Okay. Determinant of identity matrix is always 1. And determinant of 0 is again 0. And this comes, I think we discussed, no, that if I talk about determinant of identity matrix, yeah, you can just see. Whenever with respect to diagonal, above or below, all elements are 0, then says product of the diagonal. So 1 into 1 is 1. Anyway, this is very simple to expand, but if I give you this also, recall I have given you one result at the beginning of this determinant chapter with respect to diagonal elements. If all the elements above or below both are 0, then the answer is product of the diagonal, which is 1 into 1 into 1 is 1 itself. That's what here. Determinant of 0 is anyway 0. All elements are 0. Here adjoint whole transpose, or first find the adjoint, then take the transpose, or find the transpose for matrix A and then take adjoint, both are same. And again, inverse and the power n, nothing but A power n means multiply matrix A n times, both can be exchanged. And here, if the product of two non-zero square matrices, recalling no, if the product of two non-zero square matrices is 0, then both of them will be singular matrix. Try to understand this. Okay, just I'll give the solution part of this. We already discussed in matrices chapter that product of two non-zero matrix can be again 0 matrix. That's what we're saying. If product of two non-zero matrix is 0 matrix, what can we say with respect to determinant? If product of two matrices is 0, where both matrix A and matrix B are non-zero, but if I take the determinant of on that, as we know, determinant can be taken to each of them in product. Determinant of 0 is 0. Now this is two numbers. Now see, this is matrix representation of elements. Here both are numbers, and we know from numbers if m into n is 0, this implies either m is 0 or n is 0. This is not true in general for matrix, but this is not a matrix, it's a number. So from here, either determinant of A should be 0 or determinant of B should be 0. What is this? Whenever determinant of a matrix is 0, it is called a singular matrix. That's what we are saying. Then both of them will be singular. Similarly, one more point I want to quote is here. If A and B are two non-zero matrix, such a way that product of those two matrix is not equal to 0 matrix, then if I take the determinant of them, again it is not equal to 0. This is same as determinant of A into determinant of B, not equal to 0. Nothing but, now see, this both are number. Product of two number is not equal to 0 only if and only if m is not equal to 0 and n is also not equal to 0. I hope this point is clear. So this implies in place of m and n we have two real numbers, determinant of A and determinant of B. So determinant of A is not equal to 0 and determinant of B is also not equal to 0. This implies both matrix A and B are non-singular matrix whenever product of two matrices are not equal to 0. Now we are ready for the problems. Kindly make a note of this. Okay. Now dear students, let us move on to the next question. Adjoint of A is what? See, I'll be taking this type of question to make you understand the importance of concept. If I'm knowing the concept thoroughly, in no time you can get the answer. So adjoint of a matrix A is transpose of minus, option B transpose of cofactors, option C transpose of determinant, option D none of this. It is transpose of cofactors, option W is correct. Next, find the adjoint of the matrix. We know how to find the adjoint of the given matrix. Solution. For adjoint of the matrix A, we have to first interchange the diagonal element 1 6. Here it is 6 1 and change the sign. Plus 2 will change to minus 2 and plus 3 will change to minus 3. 6 minus 2 minus 3 and 1. Option W is correct. Okay. See the way they have given. All elements are same. Here they have extended the diagonal element. Okay, they have written the diagonal element and they have changed the sign. Okay, be careful. Next question says, if matrix A is, this is a diagonal matrix. Okay, then determinant of adjoint of A. Right, DET means determinant. So determinant of DET of matrix A, nothing but determinant of adjoint A, not matrix A. Adjoint of A is determinant of adjoint of a matrix A is equal to determinant of A whole power n minus 1. Determinant of, I have given a property for you that whenever in the square matrix with respect to diagonal elements either above or below, if all the elements are zeros, then the determinant is product of the diagonal elements, nothing but A into A into A. A into A into A will give you determinant of A to be A cube. So let's substitute here. Determinant of A is what? A cube. And n is order. And here the order of the matrix n is the order of the matrix A. And here the order of the matrix A is what? 3, because it's 3 by 3 matrix. So 3 minus 1. So A cube. Then 3 minus 1 is 2. Law of exponents. What is 3 into 2? 6. A power 6 is the answer. Option C is correct. Okay. If not just C, you have to first find the adjoint, then you have to determinant. That's what I'm saying. Properties will be our shortcuts. Next, see this question. If P is equal to this, is the adjoint of 3 by 3 matrix A and determinant of A is 4, then find the value of alpha. Let us decode this. This is P is adjoint of matrix A. P is adjoint of a matrix A. Just I wrote in math language. Determinant of A is given to be what? 4. Now, don't forget, we have to find alpha which is here. Don't forget, determinant, if I take here on both the sides, why should I take determinant? How to know? You can see they are given determinant of A value, so surely I have to use this data. Now determinant of A means determinant of adjoint A is determinant of A whole power n minus 1, we know this. Determinant of P we have to evaluate. Come on, let's evaluate here. So 1 alpha 3, 1 3 3, 2 4 4. Here it is plus minus plus. Then plus into plus plus 1. Leave the first one in column. What will get? 3 3 4 4. Minus plus is minus alpha. Leave the first row. Leave the first row and the second column. Here you are going to have 1 3 2 4. Then plus 3. Leave the first row and third column 1 3 2 4. This is equal to determinant of A. Determinant of A is given as 4. And since we know that adjoint of a matrix and the given matrix orders are same, here even though they mention 3 by 3 matrix order, from here so I can say that order of the matrix is 3. So n is equal to 3. So determinant of A is 4. Then n. So 3 minus 1. Now let us simplify. So here plus minus, plus minus, plus minus. 1 times of 3 4s are 12 minus 3 4s are 12. Then is minus alpha times of 1 4s are 4 minus 3 2s are 6. Then plus 3 times of 1 into 4 4 minus 3 2s are 6 is equal to 4 power 3 minus 1 is 2. Now further simplification here. 12 minus 12 will be 0. No problem with this. 4 minus 6 will be minus 2 here. 4 minus 6 also minus 2. So what we are going to have, minus 2 minus plus 2 alpha, plus into minus minus 3 2s are 6 is equal to 4 square is 16. A linear equation solve for alpha. We can transpose this, so we'll get 2 alpha is equal to 16 plus 6. 16 plus 6 is 22. 2 alpha. So here 2 1s are 2 11s are. So alpha is equal to 11. That is there in option A. Alu. Okay. Just see how we can use the property. Now here, thing is, not just memorizing the result, how to apply them is very important. In this here, as soon as I saw, okay, adjoint is given, we could have also thought, can you find adjoint of adjoint A? Is not matrix A. Don't forget, it is determinant of A whole power n minus 2 into matrix A. There will be a multiple. Determinant multiple will be there. N is equal to 3 here. So determinant of, adjoint of adjoint A is equal to, we know that, what I'm saying is, if you could have not thought like this, we could have went for a very lengthy manner. We have to find, because I have got P is what? Adjoint of matrix A. If I want to find matrix A, and if I think of finding twice the adjoint, then then we are going to have determinant of A whole power n minus 2 into matrix A. So double time when you take adjoint, you not get matrix A, you get a scale multiple also, since n is equal to 3, 3 minus 2 is 1, so you get determinant of A. Then think about 4 times of matrix A will get. Okay, so it will be a lengthy process for us. So we can just find like this. Okay, anyway, this is not required. So what I'm trying to comment and make you understand is not just the properties, knowing the properties. Knowing the properties is not sufficient. You have to apply them. So the formulas, the concept should be in your fingertips. That's what I mean to say. Okay, make a note of this. Dear students, now let us move on to the next question. Question number 22. Question says, if matrix A is given by this, then determinant of adjoint of A. So let us go for the solution. We have to find determinant of adjoint of A. So in place of finding the adjoint and then take the determinant, we can directly take the adjoint. You have seen in your PUC 5 mark question, you have to take transpose of cofactors, correct? So in place of that, we can directly go for this. But I'll be also teaching you a shortcut method how to take adjoint. Okay, but compared to that, if you have been asked a determinant, this will be more efficient compared to, that's what is determinant of A whole power n minus 1. Let us find the determinant of A. I'll find it here. Determinant of A is equal to, plus minus plus. So 2 times of, leave the first row and first column, will get 2 1 0 2. Then minus 1 times of, leave the first row and second column, you will get, leave the first row and second column, 0 1 1 2. Then plus 0. Everything is 0. This one. Okay, now simplify. Plus minus plus minus. So 2 times of 2 2s are 4 minus 0. Then minus 1 times of 0 minus 1. So here it is 4 and here it is minus 1. So I'll get 2 4s are 8 minus minus plus 1. So determinant of A. Therefore determinant of A is equal to 9. Okay, put here. Determinant is what? Determinant of A is what? 9. And n is the order of the matrix A, which is of 3. So I can write 3 minus 1. 3 minus 1 will be 2. 9 square is 81, which is in option blue. So option B is correct. Fine. Moving on to the next problem. Question number 23. If find X if this matrix is singular matrix. Recording now? Yeah. The matrix is said to be singular if the determinant of this is what? 0. So the given matrix A. So 1 2 x 1 1 2 2 1 minus 2. So again plus minus plus. So 1 into, leave this 2 and column, we are going to have 1 into minus 2 is minus 2, then minus 2 here, then minus 2 times of, again leave this 2 and I'll get minus 2 2 are 4, then plus x, again 1 into 1 1, then minus 2 is equal to 0, this is at minus 1, minus 2 minus 4 will be minus 6, this will be minus 4, so plus into minus minus 4 here, then minus minus plus 2 6 are 12, then plus into minus minus x is equal to 0, this will be 8 minus x is equal to 0, transpose x is equal to 8, x equal to 8, option B is correct. Okay, now you see this matrix question says find a 2 by 2 matrix A such that this, if I multiply this with this matrix, I'll get 6006. Method number 1, we can assume matrix B to be 2 by 2, A B C D as the entry, multiply, we'll get some equation and solve the find the value of A B C D. Other can be take the option, multiply with this, and the option giving this matrix will be our correct answer. Other, for this particular question, see the right hand side. It's a which matrix? Scalar matrix. And I gave you the concept. I gave one concept. What? A into adjoint of A is equal to adjoint of A into matrix A is equal to determinant of A into I. If determinant of A is not equal to 0, we are getting it to be a scalar matrix after multiplying with identity matrix. So as soon as I saw this, no, it clicked for me. Yes. So this, since here it is A, there it is my adjoint of A. Since there is a matrix B, this I can regard as adjoint of matrix B is 1 minus 2 1 4. And for order 2, if order is 2, recall we have already learnt adjoint of a matrix A is A itself only for order 2, and here the order is 2 only. Okay, and here also they are specified. So matrix B will be adjoint of the matrix B. And how to get that? Interchange the diagonal element. Yeah, 1 and 4 interchange. So here 4 and here 1, and change the sign. Minus 2 will change to plus 2 and plus 1 will change to minus 1. 4 2 minus 1 1, option A always correct. Next one question on finding the inverse, a straightforward question. What is the formula to find A inverse? It is 1 divided by determinant of A into adjoint of A, where determinant of A is not equal to 0. So coming to the solution, determinant of A will be, here it is plus and minus. So 3 to 2 is 6, then minus to minus plus, 1 1 are 1. So answer will be 7, which is not equal to 0. First, determinant of A should not be equal to 0, only then inverse exists. That's why I said invertible. A matrix is said to be invertible if and only if it is non-singular. Nothing but determinant of A should not be equal to 0. Substitute 1 divided by 7. Adjoint of A, how to get? Here, coming to diagonal, extend them. Here you'll get 2, then here 3. Then for non-diagonal, change the sign. Here it is plus. This sign is not taken now, correct? Now, for matrix you should take, not for determinant. Now, change the sign. Plus 1 will change to minus 1 and minus 1 will change to plus 1. I have changed the sign, not interchange the sign. So A inverse is 1 by 7, 2 minus 1, 1, 3. Yes, option A is correct. Option A. Kindly make a note. Dear students, let us move on to the next question. If A and B are given, we have to find what is the value of B inverse into A inverse. See, even though B inverse and finding A inverse is not a difficult job, but see, first you find B inverse, then A inverse, then you have to multiply. In place of this, we can use the property that B inverse into A inverse is AB the whole inverse. I can save a lot of time. Now, since we know that inverse of a matrix is 1 by determinant of A into adjoint of A, and inverse exists provided the determinant is not equal to 0, nothing but it's a non-singular matrix. So in place of A we have AB. So AB the whole inverse will be, in place of A, substitute AB. So 1 divided by determinant of AB into adjoint of AB into adjoint of AB. Just we can multiply these two matrices and then we can get the answer. So first let's multiply the matrix A into B. So row versus column. 2 ones are 2 minus 3, correct? 2 minus 3 is minus 1. I hope at least now you should be able to do the multiplication faster. 2 ones are 2, 3 into minus 1 is minus 3, 2 minus 3 is minus 1. Then 2 into minus 2 is minus 4, 3 3s are 9, 9 minus 4 is 5. Next, second row, first column. 1 ones are 1, minus 1 is plus, 4 ones are 4, 4 plus 1 is 5. Next, 1 into minus 2 is minus 2, minus 4 into 3 is minus 12, minus 12 minus 2 is minus 14. Okay. Now, from here, let us find the A inverse. Therefore, AB the whole inverse is determinant of AB. Either you can find from here or you can find determinant and multiply. But the numbers are quite small here, so I can take determinant of AB here itself. So minus to minus plus, yeah, plus minus, minus minus plus, 14 ones are 14, then minus, 5 5s are 25, this will be minus 11. So determinant of A into B, determinant of A into B is minus 11. And now done. Determinant of AB is minus 11, and then adjoint of this AB will be, as you can see, adjoint of AB, the whole inverse is here. When you're finding the inverse, this sign are not taken into consideration. I just put the sign for expansion of determinant 2 by 2. So we have to extend the diagonal element. So it will be minus 14 here and minus 1 here, and then change the sign. Plus 5 will change to minus 5. Again, plus 5 will change to minus 5. As you can see, 1 by 11, negative is not this. So negative you multiply in. So I'll get 1 by 11. Minus 1 is plus 14. Minus minus is plus 5. Minus into minus is plus 5, minus into minus is plus 1. So therefore AB the whole inverse is 1 by 11, 4 5 5 1, sorry, 14 5 5 1. This, that is there in option Alu. Okay. Now question number 27, 3 by 3 matrix is given. We have to find the inverse. 5-marker question if you have remembered. First you have to find determinant of A, then find adjoint of A, and then you are going to use this formula and then get A inverse. That method is known. The other two tricks which I am going to say, what trick? The one more which I am going to say is properties. We know that A into A inverse. A into, sorry, I think now. A into A inverse is same as A inverse into A is equal to what? Identity. So if I multiply this, the option after multiplication, and the scalar is 1 by 80, after multiplying, I should get identity matrix. The option giving that identity matrix, that will be what? The inverse. Okay. Multiply this with the option which will give what? Identity matrix, that will be the answer. So when you have got this method which you are just saying, then why you want to teach one more new method? There is a reason. Next problem will take than saying 101 thing, is better to work out that problem. So before taking that problem, I want to finish with this. Now first, always whenever inverse is asked, check for whether inverse exists or not. Nothing but find the determinant. Since in this option none of this is not there. What is not there? None of this. Surely, and either none of this or does not exist is not there. Surely inverse exists. If the chance was there that inverse could have not existed, in the option they could have either said does not exist or none of this. So there we have to be bit extra precaution. But now since they have not given as such, so surely for this question inverse exists. Now what is the shortcut method? Very simple. First take the transpose of this. Now take the transpose of this. This 6 minus 7, 8. The first row will become first column. Again, this is the second row, will become second column. Third row will become third column. Okay. Again copy the first column here. Then second column again here. Just repeat it. I just copied again this and then again copied this. Similarly, in the row, copy the first row and then the second row. Okay, let I erase this, whatever I have given the line to avoid confusion. So what I did, first you see this part of the matrix, I have taken the transpose of the given question. Correct? Then first column I have copied again, second column I have copied again, First row I have copied again, second row I have copied again, nothing else. Now what we are going to do is neglect the first column and row, first row and first column, only the thing which is inside, those we have to play now. So adjoint is given by, or better I write directly, inverse is given by. Just see carefully, pay attention, no transfer, nothing. Just for each of this you have to find the minus. I mean to say, for this find the minor. See, this is rejected, this was rejected. So here for this find the minor. So plus here, minus here, correct? So minus to minus plus, 3 4s are 12. Then of this minus 1. Next for this entry. Now find the minor of this 2. This, okay, then erase this to avoid confusion. This is done, erase this. Now find the minor for this 2. Now what's the answer? Here it will be plus and here it is minus. 1 into 8, 8. Minus minus plus, plus into minus, minus. 7 4s are 28. Then right here. Now again I am erasing this. Now what? Find the minor of this. Not related. Again plus minus, correct? Minus into plus is minus, minus into 7 into 1 is minus 7. Then minus minus plus, 3 into 8 is 24. Done. Now to go for this, find the minor of this. Again what? Plus minus. Then what happened? 1 into 2 is 2. Minus minus plus, 4 1s are 4. Done. Again, now I have to find the minor for whom? For this 2. So here plus and minus. Minus into plus is minus. 6 4s are 24. Then minus 8 into 2 is minus 16. Okay. Then again find the minor for this. 8 into 1, 8 minus 6. I hope this is clear. Now come on, do for this also. Find the minor of this. Plus minus, not try to do orally. Plus minus 1 1s are 1. Then minus minus will be plus. See, don't forget, when you multiply this diagonal, no problem. When you multiply the non-diagonal, you have to multiply with a minus n also. So minus minus plus, 3 2s are 6. Again, multiply, cross multiply. 2 into minus 7, minus 14. Then minus 1 into 6 is minus 6. Again, 1 into means 6 into minus 3, minus 18. Then minus into minus plus 7. So now simplify this. What we are going to have? This will be 11 minus 20. Then this is how much? 7 4 minus 7. If we do, how much will you get? 17, na? Yeah. And then 6 and then 40. Then 2, 7 minus 20 and minus 11. So where is 1 by 80? Sabah, this is only adjoint. This is only adjoint. Don't forget, A inverse is 1 by determinant of A into adjoint of A, where determinant of A is not equal to 0. This part is only adjoint. Determinant of A is given. Okay, now let us find determinant of A. Recording, no? Determinant of A, I have to get, either you can get from here, or very simple. You can just multiply whatever you have got the first row with this, whichever we are neglected, 6.2. Nothing but you are multiplying the first column with its cofactors. Don't forget, this is transpose of cofactors. So come on, 6 into 11 will be, write it here only in place of here. Okay, it's understood here. Okay, 11 into this 6 will be 66. Then 1 into minus 20 will be minus 20. Then 2 into 17 will be plus 34. So check it out. 66. Okay, so minus 20 plus 30 will be how much? 16. So yeah, 16, no? Sorry, 14. 14. If I simplify this, I'll get 14. 14 plus 66 will be 80. And this is there in option Alu. Okay, kindly make a note. So you have to make sure once you practice, twice you practice, thrice you practice and get perfect. Rewatch this problem. Okay, fine. Kindly make a note. Yeah, dear students, let's move on to the next question. And because of this type of question, I just taught you how to find inverse of 3 by 3. Question says, and not that it has not come in previous year. Previous year question paper, if you see, surely one of the year in Kcet they have asked 3 by 3 inverse as well. So either you can multiply with the option get identity or usual method of PUC, which is bit lengthy and time consuming. The other which I thought it is bit time consuming but not too time consuming, okay, and you'll get faster. Now see, for this type of question, if A is equal to matrix given, then adjoint also takes the same amount of time, except that you have to find determinant of A. Now that's the reason. Coming to adjoint, only thing is we are not going to find determinant. So for this, when I first write this matrix transpose, so I get -4, -3, -3, and then 1, 0, 1, then 4, 4, 3. Now whatever is there in the first column, copy again. Okay, whatever is the second column, copy again. What is in the first row, copy again. What is in the second row, copy again. Then what we have to do? The first row and the column should be striked out. Don't want this. Now start writing the adjoint of A. Now a bit faster, right? Plus minus, we have to take the minus of this. 3 into 0, 3. Whenever you cross multiply, diagonal element, no need of multiplying with negative sign. But for non-diagonal, you should multiply with the negative sign. Don't forget. 0 into 3, 0. Minus 4 1 4. First part done. Then, moving on to this entry. For this, I have to multiply this to 4 into -3, -12. Then, minus into minus plus. When you're going to go for non-diagonal, you have to have one extra negative. Minus minus plus, 3 3 is a 9. Then again for this 2. -3 into 1 is -3. And minus 2 minus plus 3 into 0 is 0. Then for this 2, 4 1s are 4, 4 minus 3. Then again for this 2, 3 into -4 is -12. Then minus plus 3 4s are 12. Then -3 and -4. -3 into 1 is -3. Then minus plus 4 1s are 4. Then 4 1s are 4 minus 4 into 0 0. Again -3 into 4 is -12. Then minus is plus 4 4s are 16. Again this 2. -4 into 0 is -0. Then minus plus 3. Now what we are going to have? -4. Then this is -3. Then again here -3. Then 0 plus 1. Then 4. 4 and 3. This is adjoint of the matrix A. Now in the option they're talking about the comparison. So one of the options is matrix A itself. You see, here we have got 4 minus 3 is 1 only. No, this is equal to matrix A. Option C is correct, but option D says option what? A and C is correct. So check A. Find the inverse. To find the inverse, we know that to get A inverse, from here you see carefully, we want 1 by determinant of A, correct? So in place of finding determinant of A from here, let us have that habit. So how to get this first row should be multiplied with what? This, correct? No, sorry. Yeah, should multiply from here for here. So -4 into -4 will be plus 16. Then 1 into -3 is -3. Then 4 into -3 is -12. How much is 16 minus 3 minus 12? -3 minus 12 will be -15. -15 plus 16 will be 1. 1 by 1 will be 1 itself. So this is your A inverse. So A inverse and adjoint and matrix A all are same. Option D is correct. Option D is correct. Now come this problem. So that's the reason I have taught you this. Okay. Now come to this question number 29. If A is equal to given, then we have to just comment whether inverse exists, does not exist. Determinant of A is equal to 2, and none of this. Surely no. If determinant of A is not equal to 0, then inverse exists. So there is no meaning of this option. Okay, so let us find determinant of this. And in this case, if you see, third column have got more 0 and third row have got more 0. So either I can go with third row or third column. Let us expand along third column. So along third column, don't forget the diamond sign. So for third column, here should be plus, then minus, then plus. So plus 0 into anything is 0. Then here for this minus 0, anything 0. Then plus 1. Leave this one column. We are going to have secant theta, tan theta, tan theta, secant theta, plus minus. Secant to secant, secant square theta minus tan to tan, tan square theta. What is secant square minus tan square? 1. Determinant of A is 1 and 1 is not equal to 0. This implies inverse does not exist. Sorry, inverse exists. What is the condition for inverse to exist? Determinant of A should not be equal to 0. Nothing but determinant of A, when I say not equal to 0, the given matrix should be non-singular. Anyway, inverse exists. Coming to question number 30, it says, if for a non-singular matrix A square is equal to I. If A square is equal to I, then what is A inverse? Method number 1 will be take matrix A has to be ABCD, then square it, then equal to identity base of time. Just common sense. A square equal to I. I want A inverse. Either pre-multiply A inverse both the side or post-multiply. So as soon as I say multiply, okay, pre-multiply to be very specific, pre-multiply A inverse on both the sides. So how to get the idea how to multiply A inverse? I want A inverse. And it's not there. It's the same like your 4-mark question, no? Prove that one equation given in terms of quadratic, in terms of quadratic in terms of A, then we have to find A inverse. What we used to do that? Multiply A inverse both the sides for 4-mark question. Same here. So A inverse into A square is equal to A inverse into I. A square is same as A into A. Then we know that whenever you multiply any matrix A with identity, you get back the matrix A itself. So A inverse into I will be A inverse itself. Then again, what is A inverse into I? Whenever we multiply any invertible matrices with the given matrix, then it is identity. So A inverse into A will be I into A is equal to A inverse. Again, what is A into I and I into A? Both are what? A itself. So A is equal to A inverse. So A is A inverse. So they ask what is A inverse? A inverse what? A itself. So option A is correct. I hope this is clear. Kindly make a note.